Thank you and good morning. Good morning. I don't see your hands. Are you ready for day 2? Yes? Yes, we're ready. We are all ready. Welcome. Welcome. Come in. So today we will have also very exciting presentations and interesting presentations, but I want you just to change the way of appreciation, because when we say it is okay how we do that, we're applauding, right? We're applauding, but if we say, for example, that it is really, really good, what other combinations of fingers do we have? We have this combination, right? We have this combination, but I want you just to use these combinations. No, not any others. Yeah, we can see to the presenters that it was good and applause. It was so-so. So it looks like that we need some improvement there, or it was bad. Don't be shy, just show that. This is the place for the improvement for us. I believe you will not show this one, but you can still show this, well, goodish, or badish, or fantastic. So please show this thumbs up or thumbs down or some flowing, let's say. And today we will have the presentation from some technical issues, well as yesterday, but yesterday we had also some community part. So at 10, already now, we'll have the presentation about common approach where we are going. So this is about the routing intelligence from RIS, and my friend and colleague from RIPE NCC Days will make the presentation of that. We will have the presentation from yesterday's speaker, from Alex Semeniak. I guess you already know him quite well, and he'll talk about new technologies in routing security, BGP roles, and ASPA. We will have then the presentation from our bright colleague from Amsterdam, Anastasia Pak. You know her? Who knows Anastasia? Okay. Anastasia. Yeah. Here is Anastasia. She will talk about the RPK deployment and IPv6 uptake in the Baltics region. Then we'll talk about the IPv6 itself. We are talking about this IPv6 already for ages, but we will see also what is happening in this region with IPv6 adoption rates. Of course, we will have lunch and we will enjoy it. I will talk also about the capacity building with the RIPE NCC Academy. This is all about the tools and instruments we can give you to have your capacities higher to do your work. So we have a lot of instruments for that, believe me. And then we'll have the RIPE-STAT, live and kicking. Again, Tees will represent this. This is really useful instrument for engineers and decision makers. And at the end, we'll have a bright presentation from, I guess you already know Eric, right? We have the delegation from Romania here, and they will share their experience, how they do the things, and how they have this great community and great infrastructure in Romania that always improving, and they will have also they will also represent it at RONOC meeting in September. So, and at the end we will have really interesting statistics, and these statistics will give you a real example of what we have done for this, not even 2 days, because we had also the trainings, these 4 days, how many people have got the certification, and we have growing number, as I mentioned yesterday, and you will see these people by names, and you can approach them in future. And we'll have at the end, at 4 o'clock, the closing reception. So you will enjoy the networking just after the event, and we'll try to make final agreements on what to do next, and also get your feedback to understand what we can do more for you and how you want to get engaged with RIPE NCC as well. So if you don't have any comments on the agenda, if you don't have any suggestions for the agenda, we can start. Do we have any comments and suggestions? No? No? Okay, so how do we assess the agenda today? Is it good? Is it so-so? Is it bad? Is it good? This way, okay. So let's ask Tis. Tis, please come here. Floor is yours. Yep. Welcome.
Welcome all. Thank you. Let's see if this one works.
I think this works if I stand in the right spot. So my presentation will be on. I'll just keep using this. I'll try to use this one. I think that's better because the other one I need to be in the right, exactly one spot.
Closer? Okay. Let me see if this works. So my presentation is on RIPE-RIS, which is a tool we have at RIPE-Stat which collects BGP information. It's different from what you do in a router, but it's a different way to look at BGP. And I can kind of make a choice. I don't know what the room wants. If you want to have a few very complicated examples, I have a few very complicated things at the end that I can show you. And I'll probably ask about that at the end, because let's start with the introduction. I'll show some ways of how it can be used. And at the end, I got some real examples of how you can use the data with some programming, maybe with an LLM to use it yourself. But okay, let's start. RIPE-RIS is a route collector project that started in 1999. It's one of the 2 route collector projects worldwide. There's RIPE-RIS in Europe from RIPE NCC, and there's RouteViews in the United States from the University of Oregon. And we collect BGP data over time, and it's a collaboration where we do the infrastructure, we run the route collectors, the servers, and the community provides the BGP sessions, provides the data, and that's then used by the community and by researchers. So we collect the data and we store everything that we get on our peering sessions. We store these BGP updates that we get, and we store the RIPs at a certain point in time, so you can see what the global routing table look like. And we and others use that to analyze the data. So it's used in a lot of research about the internet by academic researchers. We use it as the data that's behind RIPE-Stat, which I'll do a shorter presentation on later today. It's used by RIS-Whois, RIS-Live, and a bunch of open source tools use it, and there's some commercial tools that use it. And what I will start showing now is how this fits together and how this differs from a regular router in the network, because we have a network of these route collectors, of these servers. We have these BGP peering sessions, but we don't use this to route internet traffic. We use it to capture data. So the role is different. So what we've built is a number of servers worldwide called route collectors, as standard Linux servers that run ExaBGP as a BGP daemon to have peering sessions. We have a peering session with the other party, but usually a router receives the BGP updates, builds adds RIP in, collects the routes, builds the forwarding table, etc. But instead, what we use ExaBGP for is to receive the BGP updates, not look at them too carefully, because we want to see strange updates as well, because that's what you need when you're debugging something, and just store this data. So we collect the data and we ship it back to Amsterdam. And we have a lot of peers configured. Not all sessions are up, but we have around 350 full tables and a lot of customer sessions as well. So if you look at our RIP over all the sessions we have around 266 million v4 routes, 84 million for v6. And on average, we process 17,000 BGP announcements or route announcements or withdrawals a second. And if you look at the the absolute peak of what happens in 1 second. I had a lot of trouble with calculating that because sometimes it's very high when a session resets, but on average, in a busy second, there's like 50,000 changes that happen there. Now, if you look at it, we have the route collectors that we have. Historically, they were mostly at IXPs because that's where networks interconnected. And nowadays, we have a few as well that are in Amsterdam, and then we have a multi-hop BGP session. So that's a BGP session where there's no forwarding part, but that's where we just have the BGP session itself with TCP over the internet without enforcing the path length. We collect the data on the collectors with ExaBGP. We put it in Kafka, and then we process it into a lot of different data products. And I'll talk about a few of those. I'll talk about a few of these now and later today. A few now, and then there's just the raw data that's being reused by that's being reused to create the data sets that we distribute that are then used by the other tools. And what is a bit interesting here, which you may not realize, is I said that we run ExaBGP here on the collectors. That doesn't calculate the table. That doesn't calculate the routing table, but we only calculate the routing table later. When the data arrives in Amsterdam, we calculate the routing table and we reconstruct it from the BGP updates. So we capture all the data, we capture all the changes, and we also have the routing table over all these sessions, but different than from a regular router. Now, I wanted to show some new numbers here with analysis on the local internet in the Baltic states, but that unfortunately wasn't finished in time. But what I could do was looking at just the data volume that we have. So we have a lot of sessions, and there's around 1,500 to 1,700 sessions that are active at any moment in this route collector project. So if you see some strange announcement or effect that you noticed in your routing table when you're debugging an issue, because there are so many of these routing sessions, there's a good chance that our data set also captured it. So then you can use this data to debug an issue or to see like the change I made propagated this way, or the hijack that was ongoing. You can look back in time and seeing what was happening, and I'll show some examples of that later. What is difficult here is that storage is not free, and if you collect a data set and you're never going to throw it away, it means it only grows, and that has two big problems. Well, one is just for us, because if you have more data, it gets more expensive, and that's why we don't want it to grow too hard. And we also notice that for our users, the data gets very big. So we have 23 places where we collect the data, but then researchers write in their papers that they selected only 1 or 2 of them. So then the question becomes, why collect all the data when nobody is using all of this? So historically, we accepted any peering session that somebody offered with a very open peering policy. But because of the data volume, now we have had a selective peering session for the last few years. And we are now looking at it to change it even a bit more and really actively choose what networks we want to pair with, because if you look at the internet, the interesting events happen where there's a lot of connections between networks. They happen at the edge of the internet. But if you have 10 peering sessions, if we collect 10 sets of data from networks with the same peers, the first one adds all the new information, and the other 9 just repeat the same updates. So we need to be very conscious with what we collect. And there's 2 parts of that. First, one part is us doing data science, and it's extremely difficult to choose something that you feel comfortable with. So I'll try to catch some of you guys later for today is to also hear a bit of the stories about how interconnection works here locally, what the role of IXPs still is, and etc. Because doing this purely from data is very difficult. But while it's very difficult to make a decision on pairing with the data, you can actually reuse the data quite well for various tools. And okay, I have to plug our own one, which is the most one of the most valuable things that we do for our registry department, also for our users, is to really look back over time on what was happening with an AS or with a prefix. So with this data set, because it started in 1999, we can just, for a prefix, we can just show how it was announced. Or for an AS, we can say, what has this AS ever announced over the years? And how did they change it? What did they do? And for example, in this case, the network deaggregated, but it's not really visible. So that probably means that either this was, the RPKI configuration was not good, or they didn't advertise it to all their peers, maybe just to customers, etc. You can really see what happened and how the behavior changed. And also, if you get a new customer that says, okay, we advertise these IP addresses are ours, you can check like, okay, was this, does this look right, basically. And another one that we run that is used by some tools, this is behind some of the traceroute, is behind one traceroute implementation, and I'm not completely sure which one, is RIS-Whois, which is a Whois style database where you can see the origin for a route. It's not a small service. And I'm just saying that data science is difficult, or well, data science is, you need to be very careful when you do it. So academics use this data as well, and we use this data as well. So my colleague Emil, who presented yesterday, also likes using this data. And we did a preliminary analysis of how the BGP was affected by the cable damage last year. And what you see happening here is that if you look at what's happening in BGP for a prefix, there's always some churn, there's always change. So if you looked at the BGP timeline during this, when the cable was damaged, the line, it's always jumping up and down. It's always noisy, you didn't see it. But after some careful data analysis, you can see that some prefixes that usually are pretty stable had a spike in there. And we hope to write a full-on article about this in the future, because there's signal there if you want to look. Then the beauty of these routing data sets that we create and that RouteFuse create is that they're available for download and for reuse by other parties. So there's a lot of academics and commercial projects that use it, and one that you may know, for example, is SCADA AS rank, where they look at the relationships between networks. So what is a provider, what's a customer, and they infer the customer cone of networks. And this sounds all very abstract right now, but when we talk about ESPA later today, you'll realize that you need to know what all the providers are for a network, and that you need to know the complete set of providers. And that's where this data will also help us in the future to not claim what the providers are for a network, because there might be some peering session that's a backup link that we never see in the data. But when you put in your list of providers, we can tell you that, hey, we think you're missing one because we've seen it. And that's where the data is very valuable. And you can also use it for analyzing incidents. And there was a very recent blog by Cloudflare where they looked at some very interesting hijacks, where the peer AS of a transit provider or a large network, where the pair of a transit provider of a large network advertised routes with the next hop that wasn't their own AS. So they pretended to be another AS on a peering session, and that way they could avoid a lot of filters. And a lot of networks prefer routes from their customers over transit. So there were some quite effective hijacks that were done this way. And the blog is much better explaining what actually happened. It was published yesterday. I really recommend that you read it because it's interesting. But what they show in there that I really liked is that they showed two ways, in a very practical way, where how they use tools to look at this routing data that's collected. So on the right side on this screenshot, you see that they use a CLI tool, Monocle, to search for the BGP updates for a certain prefix at a certain point in time, and you just get a list of the updates with the AS path. And they used it for this, to analyze this incident, but you can also do this yourself to look back when you made a routing change, like, okay, I did this routing change yesterday, how did this propagate to the default free zone? Or, okay, I wanted to do some traffic engineering, so I changed some prepends, and now I want to see, like, I take a look at yesterday's data, I want to see, like, what providers all the networks preferred, and now I can look at the state of today, after the change. And you can do this with Monocle, and another thing that they showed in the blog post was actually a nice viewer that they recently built to view the raw data that's in the files we create. So we create these files with the BGP updates, you find the URL. That's a bit tricky. If somebody tells you one, it's easy. And then I actually showed you what's in there. And this tool shows you that these files are just zip files with encoded BGP messages that you can then filter to see the BGP events. And the CLI workflow I just showed is kind of complicated, and I'm a software engineer, not a network engineer, so the tools I like using are different than what you use. So I don't know if the CLI is sounds easy to you or it sounds hard, but what I'm very used to as a software engineer are APIs, and one very good one that we have based on this data, and it's part of RipeStat, is the looking glass that's in there, which is one of the few data sets in RipeStat that's real time. But there's a real-time looking glass over all these 400, over all these pairs, these 400 plus full tables that show you the paths towards a prefix. And people use this for monitoring or for looking how their Anycast deployment works, etc. This can be both a tool to look at through a web interface at one point in time, but also to build monitoring on or to see what's happening. And we are working on that one. Then if you want to build even more software and want to build something more interactive, there's also a live feed of the BGP updates for a specific prefix that you can get through RIS Live. And this is the tool to get really quick updates without waiting for the files to be created. And you get the BGP updates take like 10 seconds between being transmitted on the internet, being captured, being put into Kafka. Like, remember the big architecture diagram in the beginning? It takes around 10 seconds for the messages to make it from all the way on the left from the peering sessions into our infrastructure and into this WebSocket. So you can really build something that's very responsive with this. And as a software engineer, I would say it's easy to use from your own code. It's much easier than using the other tools, but it's difficult. So the case I wanted to make here is that RIS is one of the tools is used worldwide to capture the development of the internet and what's happening in the default free zone, and that you likely are using tools that use this data, and that you can use this data yourself, like with Monocle or calling this Looking Glass API. You can do this yourself, and you can also do something even more complicated. So let's check if there are any questions right now. And if you guys want, I've got two more complicated examples at the end, but then we'll actually show code. So that's a bit tough at 10 in the morning. But yeah, let's see. Shall I show code? Okay. I'm happy with this. Do you guys want to be scared with code, or shall we skip the code in the morning? Code? Okay. Something I wrote up on Ripe Labs a while ago was a way to put data into, to take these files and put the data into ClickHouse. And that way you can do, I got better and better at SQL over the last year, but that way you can actually do queries on the full routing table. So you can see how often certain transit providers appear in paths, etc. And you can be very creative with this. And that's what I use myself now doing some analysis. So you can play with the data in the database. There's a full tutorial in the blog post of how you can do this. And we will post we will also post a blog post soon on another way to do this, where you don't even have to create the data where you don't have to index the data yourself. So that's one complicated example. The other one is I showed Monocle here earlier, which is pretty well. You can also do what people used to do, which is you can just download the files and pipe them through a tool that reads it and then grab. So like a full-on CLI workflow where you have all the components in your own hands, no magic on the background. And the third one is, since I'm a software engineer, this is Python, and Python is very easy because it's just code. And what happens here is that you import a library, BGPcat, you select the time window for what you want to have the data, and you say you want a RIP, which is the full table, not the BGP updates. And you can just iterate over the routes and do data analysis this way. So yeah, this is the complicated way to go. It's natural for me, and I hope I didn't scare you with the code this time in the morning. Thanks for your attention. Fun to show this. Yeah.
Do we have any questions? You have a question. Okay, welcome.
So hello, Tees. As I know, there's lots of internet websites that use RIPE. I am Joanna. Hi, everybody. Hi. Yes. So as I know, there's lots of internet websites such as Cloudflare or BGPlay that use RIPE rich data to complete their internet measurements. Is that correct? Because I think there's some organization that use our RIPE rich data to complete their measurement or use as their measurement tools. And as you just mentioned, somehow we could also use RIPE rich in our daily life, but we could not just notice it. And is there a well-known example that everybody could use the RIPE rich data every day that you could share?
And I think the thing that people use every day, or well, every week, is when something happens like the blog post that Cloudflare makes. That's when that's something that cannot be done without this data being collected. The other tools, the tools in RIPEstat, BGPlay, and these exist, but they are less day-to-day. You need to know about them. So you're right that there's a bit of a situation where sometimes it could be that it's not that visible that the data is being used. And yes, that's something that these projects struggle with a little bit. Yeah.
So who is using RIS? Just raise your hand. Not you. Okay, one. I have you. Two? No, not you. Okay, you're from just one person, two people from community. Okay. Who is using RIPEstat? Not you. Not you. You? Okay. And you? You also? Good. So another two. Already 4 socks. Okay. And what other tool you have mentioned? RIPEstat, RIS. What else?
RIPEstat, RIS, blogs. It's in Cloudflare Radar uses it a lot.
Okay, let's stop on this.
There's a lot of stuff.
4 stocks. Yeah. 4 stocks. Okay. 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 Thank you. Thank you. Thank you, Thies. And our next presentation is from our well-known yesterday's speaker, Alex Semenyaga. Alex, just run to this stage. Yeah, go ahead. Yeah.
Please. Okay. Bahan will help me a little bit because during this presentation I will ask questions, and those who will give me some answers from Vahan will get some prizes. And okay, and this presentation is a bit, I'd say, theoretical, because we will discuss what's going on with BGP security at the moment in terms of the technology. And after that, another my colleague, Anastasia, will deliver the talk with the numbers presenting the state of technologies in your region. So they are quite connected. So I will start from a short recap, as you can see, because it's remember how did we start. Back then, internet was really, really small. It was beginning of 90s. Well, even end of 80s. Everyone knows everyone maybe through one hand. So there was no problem of trust. And the main goal of creating routing system was to provide a self-organization to this global network, because it was already global. It was hard to maintain it manually. We needed some mechanism. And because of this mechanism, which was created, had no any security in mind. What have been done, they created, they split internet into so-called autonomous systems, as you know, and created this open BGP protocol. And it was really successful. It was cool. It was wonderful. And it's still here. After 30 years, we still have this BGP version 4, which is fantastic job. But now, at the moment, nobody trusts nobody, excepted him. We trust him. So the problem now is that technologies, well, I would say approach behind the original BGP do not match first modern security standards and operational standards. What do I mean by operational standards? That the next slide, and I have a question. Vahan, why are you reading your email? You're going to help me. Tell me. Yeah. If anyone will answer, you give him here something, right? Okay. Go ahead. So the question is, whoever heard names Gao and Rexford? I know. This will be a conflict of interest. It's prohibited. Anyone else? And that's what I use in every day. Actually, these guys bring something new into the internet. So let's discuss first what we have with the security standards. We have some standard definitions for incidents. The terms we have to understand is prefix hijacks and route leaks. Route leaks, that's the situation when BGP announcement, legitimate BGP announcement, we can have this announcement, but it was propagated beyond the scope it should be propagated. And that's the definition from the, well, not from the, but from N, RFC. That's, you know, the official wording. And prefix hijack, that's the originating of announcement by some autonomous system which is not allowed to do that. It's some, you know, something wrong from the very beginning. Well, anybody knows the RFC number where we have this definition? Any ideas? That's really simple. I'm asking today simple questions. These questions are simple. You have to remember that to answer them properly. So that's a little bit. So, no, nobody. Yes. If I'm asking the number, and it's the easy question. No, it is. Okay, there is no such RFC. It was so typical from the very beginning. 2 years after BGP was created, we had the first incidents of this type. So it was something with us from the very beginning. And nobody even cared about putting these to RFCs. Vahan is sitting with his prizes and nobody is answering. Yeah, please do better job. So, and that's the statistics, that's more than statistics, current situation we have with these incidents. That's amount of root leaks, that's amount of previous hijacks. You see this number? This number are prepared by Curator Labs. That's anti-DDoS company, and anybody who starts fighting DDoSes ends up with analyzing BGP. That's the rule. So they do this job constantly, and they are publishing the statistics. And basically, you see that we have a lot of them. In average, almost every 5 minutes, we have the next routing incident in the global network. And most of them happened due to mistakes. Somebody did something wrong, and the most typical mistake is this one, fat's finger syndrome. Instead of 4, I type 5. And when, yeah, exactly. And when we have such a bad signal-noise ratio, we are not able to analyze, you know, anything any further. But that's not the only issues we have. Another goal of BGP existence is earning money. And that's really important to understand that BGP, I love this word in that BGP, it's money translated to the router's language. All development of this protocol during the years was driven by new commercial's idea how some operator can earn a little bit more, work a little bit more efficiently, but it needs some addition to the protocol to make that. So we have to understand these rules. When we started, I remember this time. I joined the internet when it was like here. It was completely chaotic. Like I have some traffic here, you have some traffic there. Maybe you can provide me with this, and I will provide you with that. And oh, we are not far from each other. We can establish a link. There was more technical considerations how to make it works at all, not commercial ones. But that's not the case anymore. Many years passed. So now it's quite organized. We have commercial hierarchy. We have tier 1 operators. They are not paying for the traffic to anyone. They are exchanging their traffic between each other and selling it down. We have tier 2 operators. They are buying the traffic from someone from above and selling this traffic to someone who is below them. And we have tier 3 operators which are only paying for the traffic. They are not selling it to other operators, only to some end users. And to optimize these things, sometimes we have peerings. Well, actually we had peering here as well, but that's completely possible to have it below. And if we have a lot of peering, then we have the internet exchange points where people can do it in the scale, right? And for such guys, we have a special autonomous system, but this autonomous system is not visible in the SPath. That's basics, like BGP 101. And Gao and Rexford approximately 20 years ago formulated rules how traffic should be, how announcements should be propagated to make everything profitable. They stated that propagation of BGP should be based on the profit of the operator. We have to propagate our announcements in the way that traffic will bring some money to the operator. Example, we have our downstream. They are paying us. They're paying us, so we are going to send this announcement everywhere because we want this traffic. And that's how it looks like. Now we have our peer. They don't pay us. So we don't send this traffic to another free link because we will earn nothing. We don't want to send it to our upstream because in this case we will pay at the moment, at the end of the day. The final amount of money will be negative, so this path is prohibited. The only direction we can earn something is here. And you can now predict that for our upstreams, we are going to send it here because that's the way we are earning something. We paid for that, so we will not send it here and here. And of course, we will not send it here because we will pay twice. That's simple rules, and basically they could be formulated easily that announcements from below we propagate everywhere, and all other announcements we are propagating only downwards. The problem is that there is no up, down, side in the traditional BGP. It has no such a concept at all. BGP was created when the internet was flat, and it's providing the mechanism to self-organize the flat internet. So, does it mean that we can do nothing? No, it doesn't. For decades, industry tried to add something to BGP, including in this sense. Industry tried to improve the situation. Some approaches died because they didn't fit the reality, but some are still on the table, and we have some of them starting implementing. Some of them are in the queue, but we are expecting them soon. Let's see what do we have. First of all, that's something to remember for future material, that we can't verify anything from inside if we have no external sources. Like if I approach you and I tell you, I'm Alex, you need something external, like if you want to be completely sure that I'm Alex, you need my passport, or you need someone you know to tell, yes, he's Alex, or something like this. If I tell you twice that I'm Alex, that will not improve the situation. So we have to have some external source of trust. We have to cover somehow business relationships. Without that, those numbers I showed you will be improved, but they will be still quite problematic. And we have to understand that we can't make a revolution. We have like 500,000 BGP speakers in the internet, and that's impossible to make people upgrade all of them, switch them to something new and fancy. That can be only the gradual process. So we have basically, what do we have? We have RPKI, and it's so typical that people confuse RPKI and ROA, which is the part of RPKI. That's true that ROA, for a long time, was the only part of RPKI we had working. But still they are different. RPKI is a framework. That's the centralized framework which can be extended. We can have different building blocks of this framework. And ROA was the very first one, successful, well-known, but the very first. Now we have the second one almost here, called ASPA. This mechanism is completely external to BGP. We do not change BGP in any sense. It's an additional mechanism for routers to check announcements and source of information, what to do with this announcement, either to treat it normally or to reject that. But it does not change anything inside BGP. And in this approach, we have authorization built in, so that's important because that's what makes it secure. What this framework does, actually, it ties two types of entities. In each block, we have specific entities that can be tied. For example, in ROA, we are tying IP prefix to the autonomous system that is allowed to announce it. And we tie it using the cryptography to make it robust. But if we have some crypto signature, it means that we have to verify it somehow. And the typical approach, you see it every day, if not every hour, is approach we have in HTTPS. We have chain of trust. Same here. We have chain of trust, and on the top of this chain, we have our 5 regional internet registries like RIPE NCC. And someone who is eligible to create this connection between two entities should create them and publish. And we call this part of RPKI signing, because it signs this statement. This autonomous system is allowed to announce this prefix. But nothing will work if this thing will not be used. So we have to have other players, other autonomous system, downloading published information and using this information to work with the BGP stream. So that part is called validating. They're completely independent. And, you know, today I'm signing and publishing something. Tomorrow or next month, you are using it. They are not directly connected in terms of the time. Another approach is called BGP roles. That's simpler thing because we don't need anything centralized. We are working on the local level. We are classifying our own connections, our own sessions, and our neighbors do the same. And we follow the Gau-Rexford rules using this classification. To make it more, let me use this word again, more robust in the implementation, we also add in the new attribute called OTC, only to customer, which helps us if this extension is not deployed widely for 100% of the routers. In the last approach, some people do believe in this approach that it's so secure, it's so deep, we are doing such a good job. I don't believe in that, and I will explain you why. But it's still here, called BGP-SEC. In this approach, we are changing the basic rules. SPATH, as you probably know, is a mandatory attribute. And not anymore with BGP-SEC. Mandatory is either SPATH or BGP-SEC path, new attribute with a lot of signatures, and to do the signatures we need BGP-SEC router certificates, which are published in RPKI repositories. So BGP-SEC is also connected to RPKI framework. We have this chain signing, really fancy thing. We will see how it works. And we use this attribute both for origin, what we have in raw with usual RPKI, and transit. That's what we have with ASPA in usual RPKI. And let me finish this introduction with reminding how RPKI raw works. What do we have? And actually, that's a popular technology. It's widespread over the world. We have, you know, really good adoption of it. So probably you know that. But in short, we have binding between prefix and autonomous system, and this binding is called ROA, routing origin authorization. That's a small statement signed by the certificate of the entity who is creating this the thing. And we are publishing them, and those players who are validating announcement, they download all ROAs from all sources, filter out faulty because, well, the certificate can be expired, there can be some mistakes or something, or even attacks. And all other are used to match origin in incoming BGP announcement. So for each announcement, we check, does it correspond to some ROA? And if we see invalid announcements, announcement which breaks rules, which is written in some ROA, we are discarding this announcement. And more information is in our in our website. We have a RIPE Academy section of our website called RIPE Academy. For self-learning, there is a micro course, general introduction, 2 micro courses, sorry, and full-size e-learning course with tests, labs, and everything. So if you still don't know enough about ROA, you can go here. And also we have our training courses. One of them happened 2 days here in this hotel, and some of you probably were there. Now to the new technologies. BGP roles. Now I'm going to show you some pictures, but not at once, a little bit, a couple of slides later. What do we do with BGP roles? We have these roles now for each session. The role is specific for a session, and you can have 2 sessions with the same autonomous system, where on one session you are using one role, in other session you are using other role. So, of course, the role you are using should match the role from that side, so both sides should support this BGP extension. Otherwise, nothing will work. And if we are sending our announcement which has no new attribute OTC, only to customer, if we are sending it downward or to a site, we are adding this attribute to specify the future behavior of this announcement. So, how does it work? Basically, without OTC attribute, BGP speaker supposes to be is supposed to follow GAO-Rexford rules, as we discussed. So with this classification, it will analyze the role of peer, and it will behave accordingly regarding all announcement it's getting from this peer. That's really simple. Why do we need this OTC attribute? Because it's completely possible that some part of the path will not support BGP roles. And in this situation, like we have no support here, this OTC attribute will prevent this announcement to be sent in the wrong direction if the next autonomous systems do support that. So it's an additional mechanism, which is nice to have, but it's not absolutely crucial. Roles without OTC are already working, and they are working quite fine. Please pay attention to the path upside. You see that we have some weird part where the GAO-Rexford rules are broken, but BGP rules extensions doesn't care about this part. It cares basically about this one, provided it's not implemented partially here. So at this point, we have no verification of this thing. So to make it work, we have to have BGP roles deployed quite densely. Not everywhere, not 100%, maybe not even 75%, but to have a real effect, we need them on a large part of the equipment. But still, it can be deployed gradually, and even with a step-by-step deployment on each step, we will have some small results. the software which is supporting that, routing software, you see, all popular products are supporting. For the hardware, Juniper, Huawei, and MikroTik does not support OTC. That's why I explained you that OTC is not absolutely necessary to have. It's nice to have, it helps, but actually even without OTC, this technology works and it's quite important. Unfortunately, it is not supported by Cisco, and moreover, Cisco stated that, well, no, we don't support this one probably because we want to go for ASPA. ASPA is better, so we will support ASPA in some future, probably the nearest one, but still. So we have this situation. Let me then describe what ASPA is. ASPA, that's again the building block of RPKI. But now we are tying each other, your autonomous system and autonomous system, which is your upstream. Only upstream. We are not tying your peering partners. We are not tying your customers. We are connecting in one statement called ASPA, your SN and ISN of your upstream. And we are signing them, this thing with our certificate as usual. And when we start validating, we download all ASPAs from all the world. Of course, we are filtering out all faulty ones, and we use remaining statements to verify SPFS in each BGP announcement we get. And how we match these announcements? We have simple rules. First of all, let's call us sent the situation when announcement went from customer to a provider. We call descent the situation when announcement goes from a provider to a customer. And we call valley when we have no customer-provider relationships between two autonomous systems. And now the rule is simple. First, we can have only ascents, 0 or more. We still can have 0 of them. After that, we can have 1 or 0 valleys, not more than 1. And after that, we can have only descents in this order. So the sequence should follow this hierarchy we discussed before, commercial hierarchy, and the roles now are stored, roles are now stored in the centralized way. All world now knows who is who for who. That's a significant change, I would say, in the BGP ideology, even remembering the fact that we are not adding anything to BGP itself. It's RPKI. We are not changing the protocol. We are changing only the pre-filtering of our announcements. So it's easier to show how does it work. One, could you please come to me? I will ask a couple of questions on the next slide. So here, completely valid path. We go up, 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 up. Now we have one valley, and we go down, 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 down. Right order, allowed number of valleys, everything is fine. Same here, we go up, 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 no valley at all. We go down, 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 down. Right order, everything is fine. Now, what is prohibited? And tell me, please, picture by picture, what's wrong on each of them. What's wrong here? Why it's not allowed? Why it will be rejected? Two values, yeah. We have two answers, yeah. We have answer there and we have answer there. Please, yeah, please raise your hand to make it more easy to locate you. So what's wrong here? Right, yeah. We go here upward after a valley is prohibited. And here, no needs any socks. You are not using socks. What's wrong here? Yes, yeah, exactly. It goes down after it went up. Exactly. And you see that these simple rules, actually, they completely correspond to the Gau-Rexford rules. Simple algorithm, quite lightweighted implementation, and these rules are globally here. And we can check this path partially. We don't need ASPA to be implemented globally. We can analyze that like here or here and make some conclusions even if we don't have any information about relationships here or here. We still can check ASPA rules in remaining segments. So once again, this technology allows us to be deployed gradually. Unfortunately, the hardware support is 0 at the moment. But despite of this fact, we have two players who are probably doing this validation. That's not official. That's from speaking to people. But people told that they have a special solution. They are downloading this ASPAS to special router. It creates the classical BGP filters, autonomous system filters, and then these filters are being uploaded to routers to provide ASPA working. That's, of course, an extra job. That's not easy to do, so I am not asking you to start going this way. Probably it's better to wait until we will have this in hardware routers. All major manufacturers have ASPA in their roadmaps, but it shows how badly industry is waiting for that. We are supporting this in terms of signing. So to sign your ASPA, you need same 40 seconds as you have for as you need for ROA. It's not more difficult. It's completely the same thing. So it's easy to create these connections to your uplinks and to publish them. Believe me, 40 seconds. Our colleagues from AppNIC, LACNIC, and AFRINIC are going to deploy it quite soon, and we have validators working with that. So, yeah, and of course we have software routers, but this one is a reference implementation. So I'm not sure how does it work in the production, but this one is well known, so it can be used as well. And what could go wrong with that? Any ideas? I expected that. Oh, yeah, please. Sorry? If this is the second valley, that will be rejected. That's true. I would say that it's quite a strange situation. link, and you're sending it to like IXP or something like this. Okay, yeah. Actually, you are thinking in the right direction. Let me start with the simpler aspects. First of all, for BGP roles, as I said, even we are validating everything when we are going down. If we came to the top by a completely wrong, completely illegal path, there is no mechanism to check it. So it's necessary to have BGP roles implemented everywhere, so the way up will also follow GAO-Rexford rules. And that's not a catastrophe, but you know, it provides less efficiency than, for example, ASPA. And with ASPA, if it comes again to the partial implementation in the world, we have to analyze, you know, aspect partially. Like here we have this decision, here it's like this, and it creates some level of uncertainty. So for equipment, probably why ASPA is not here yet, it's my assumption, not official, but my assumption that it's hard to create these consistent rules of partial treatment of SPAT. Not treatment itself, but you know, rules of making decisions, what's good and what's bad. And another aspect, Vahan, I'm finishing. Yeah, give please a prize to our. Give please socks to our participants. Socks, okay. Yeah. So yeah, it's almost the end. Several slides. Another situation. Back to the beginning, we still have some chaotic things in our networks. That's true, and most typical are different roles in different situations. Like in Europe, I'm your provider. In Asia, you are mine. And for you are my provider for IPv4, and you are my provider in IPv6. With BGP roles, it's a little mess because we have to create different BGP sessions. Well, if it's different regions, that's natural, so no additional difficulties. But with ASPA, everything is tougher because we can't have different roles between two autonomous systems, and this is centralized. So either this autonomous system is our uplink or is our downlink. No any other options. So to cope with this, we have to get different ISNs and do some extra engineering. And that's not that easy. And the last one, it will be short. Here, as I said, we have a new attribute. It replaces this one, so mandatory to have either this one or this one. It's not transitive, that's important, which means that if BGP-SEC announces comes to the router, which does not support BGP-SEC, it should be converted to the traditional announcement without any BGP-SEC. That means that BGP-SEC should cover 100% of systems to work efficiently. It's much more strict requirement than for BGP roles and ASPA. And in BGP-SEC, we have two chains. One called secure path, which is completely equivalent to SPAT. And the signature block, we have the sequence of signatures. And I do believe that people who did that were, how to say, were inspired by the blockchain technologies, because that's exactly what we have. We are using all signatures from previous steps with the path information and prefix information to create a new signature. That's how it looks like. We are using all the things to create a new signature on the next step. And what does it mean? We have such a short path. We have just 3 prefixes here, but here, before propagating this announcement further, this guy should check 3 signatures from here, 2 signatures from here, 1 signature from here. With the growing size of the network, the number of signatures are growing non-linearly. And each signature should be verified right here, right now. It cannot be cached like in RPKI. It should be treated exactly after receiving this announcement. So any BGP session now means an enormous amount of cryptographic calculations, which basically means that to establish a session, you still need several hours, even in 2026. That's completely not feasible. And how business relations are described here? Anyone spotted it here? No? Yes, because they didn't. They are not described in the BGP-SEC, so we are spending so huge efforts to cover only part of problems that I don't believe that anyone will continue go this way. From the practical point of view, it's a ridiculous approach. As for me, I don't believe in BGP-SEC. So, all conclusions are obvious. No silver bullet yet, and probably never will be there. But you are washing your hands, you are brushing your teeth, completely similarly, you have to use routing security mechanisms. Do not accumulate technical debt, because they are relying each other. And it's better to start now to make your life easier tomorrow. That's it. Vahan, why you are sleeping?
I said I'm applauding. When I pass the applause, let us make this 2 thumbs up because we're finished. Thank you. Thank you, thank you, thank you, thank you. Now thumbs up for Alex. Yeah, Alex, look at them. Look at them. Show them your fingers. Yeah. Thank you so much. Thumbs up from your side. Okay. Okay, thank you. And our next presenter is Anastasia Bach, that will provide you, okay, go ahead, take your seat. That will provide you another aspect of security issues, right? Anastasia, floor is yours. Yeah. Do you need this?
I think this is fine, but maybe leave this here just in case. Good morning, everybody. Yes, I hope that you are not yet tired, because we had quite a long lecture to digest. But while you're digesting about the routing security practices, I'm going to tell you what we see, how you are doing in terms of actually deploying these technologies, and I'm going to look into the RPKI deployment and also touch upon IPv6 uptake in the Baltic states. And before we actually go into the statistics that I'm going to show, I want to look a little bit at the numbers of the RIPE registry. Actually, yesterday my colleague Jeremy showed these numbers. So here you could see the number of members in the region and number of ASNs, as well as the allocated IPv4 addresses and IPv6 addresses. So actually, I'm going to change the mics. Yes, I think that's better. Yeah, so we can. I'm going to show you statistics on the RPKI deployment v6, and this is going to be percentage of the address space. And that's why we wanted to show you this graph first, because you can see that, for example, Lithuania has a very large number of v4 and v6 addresses registered. And but for example, for Latvia and Estonia, this number is lower. But for example, the number of ASNs is relatively similar. And we also added the population data from the World Bank just to give an overview. So you've heard now from Alex a lot about the need for best routing security practices. And I want to talk to you a little bit about RPKI deployment in the region. I think I'm not going to go deep into that slide, and just to mention a couple of accidents that happened, and they really affected the global internet. So, for example, when Google Japan in 2017 accidentally leaked BGP prefixes, it resulted in a major outage. Even though it lasted for about 10 minutes, the effect of it was quite huge on the banking sector, so on the government sector, and many more. And since RPKI was in place, there were other recent outages, incidents, for example, Telegram block of Iraqi government, or the Cloudflare 1111 incident, but the effect of it was much smaller because the RPKI was in place. This one already has been explained, but just to recap, there are a couple of steps in your RPKI journey, and first is ROA, so it's step number 1. Basically defines which AS is authorized to announce a specific prefix. Then we go to actual validation, so that's where you validate the routes based on ROAs, ensuring only legitimate routes are accepted. And then the new addition to this family is ASPA, that Alex also has mentioned today, that helps mitigate routing incidents. And here, actually, so we wanted to look at the number of incidents, or let's say BGP events, in the region, but also globally. So it's the number of incidents from May last year to May this year. And they include only MOAs and sub-MOAs. So this, because these are the ones that RPKI can help prevent. And we can see that, for example, Latvia saw relatively larger number of BGP events than Estonia, only over 100, and for Latvia, over 900. But it's not comparable to, for example, US or India, Hong Kong, etc. But even a small incident, a small event can lead and cause quite a big impact on the global internet. So it's very important to have the good security practices in place. And so in terms of ROA, that's quite straightforward. In the region, the level is quite high. For IPv4 address space, it's ranging between 80 and over 90%. For v6, it's lower, but also it's important to know that there's much more v4 address space, v6 address space, and not all of it is used. But it's interesting that for Lithuania, for example, we saw the first graph. They have a really, really large number of allocated v6 resources, but 58% of them is actually covered with ROAs. This is, yeah. So I also zoomed in Latvia, so just looked at the dynamics in terms of last 6 years, and there were gradual increase in ROA coverage, and there were a couple of spikes. So in IPv4, in March 2022, it's when TED, I don't know if there is anyone from TED, I think yesterday there was. Not today. So yeah, the TED covered their v4 space with ROAS, and that contributed to the increase of the overall coverage from 66 to 83%. And for V6 space, it was when Beta in December 2021 also covered their V6 space with ROAS. Next. As we said that even minimal BGP incident can actually influence really major and important sectors of our lives. We looked a little bit in the different aspect of it as the government infrastructure. So, and we checked whether the IP addresses behind the government domains in the region are covered by ROA. Actually, to do this, we also used RIPE-RIS that was mentioned by my colleague Tis in the morning. So overall, the picture is good. So most of the IP addresses that we could find are covered by ROAS. But it's also important to know that in order to find the list of government domains, there is not really like a very comprehensive database. So we use the certificate transparency log, so this list might be actually non-exhaustive. And for Lithuania, there were only 3 IP addresses found, but actually I checked later that 2 of them were behind Cloudflare. So that means also often a lot of these domains are hosted by the CDNs or other third parties, which means that when we talk about the routing security practices for this, let's say, government infrastructure, it could be also just the security practices of the hosting providers. Of course, we would like to further actually break it down to have a better picture. And then we said ROA is your first step, just initial kind of signing, but then what about actual validation? And you probably know that ROV is really difficult to measure. We use the external methodology Rovista to analyze the deployment of ROV. And basically, you could see on the slides that it calculates the scores based on the number of RPKI invalid prefixes that AS can reach. And we used a little bit of a different approach because we classified AS having implemented ROV if the score is just greater than 0. So it could be basically any level of deployment between 0 and 100. And there is additional layer, now you will see later in the graphs. We used to visualize this through the methodology that was actually developed by my colleague, Emil, here, and it's the AS hegemony. So I'll go back. So, because it's very interesting to see how central the network is in the country's landscape. So, and then we also added basically the layer of ROV deployment to that. So basically, hegemony measures the common transit networks to local AS and how much this AS relies on these transit networks. And the values range between 0 to 1. So here you see the size of the nodes. So the size is corresponding to the centrality of this network. And then the colors are basically saying whether the AS is registered in the country, in Latvia in this case, and or outside the country, and whether they do implement ROV or not. And we see, like, for example, TED is quite an important, this AS 12578 of TED is quite important in the country's routing, and by deploying ROV, they would not only protect themselves, but also all the networks downstream, downstream. So that's, and for example, also the LATNet, also quite, it's a beta actually, it's old probably as of LATNet, and 2588. Also, if they would actually deploy ROV, we would see it green, and they would protect the customers downstream. In Lithuania, the picture is very similar, so a lot of locally registered, let's say, networks having played a quite important role in countries' routing, but also, for example, Beta but the one that registered in Lithuania, they do not implement ROV according to this methodology. So would actually maybe like to ask whether this is true, or maybe the snapshot from one day at a time did not capture the practice. For Estonia, the story is a little bit different because we see actually a lot of the ASs that registered outside the country playing quite a central role in countries' interconnectivity. We see here the tier 1 networks. And for example, yeah, also some other like CITIC here and Aurelion. So they are quite, they are quite prominent because, for example, in Latvia and Lithuania, we saw more locally registered ASs being central. This graph, you could actually scan the code and play around and check your AS, whether it's there, how you're doing, and I'll leave it for a little bit. We also added a couple of layers, so it has a hegemony, it has Rovista score, but it also has the customer population of the AS. It's developed by APNIC, so if you click on the AS, you can find its name and different information. So this has a snapshot from, I believe, a day in May 2026. So ASPA, also we just started to report the ASPA numbers, and so far, of course, it's low because we know it's quite a new technology. And here you can see the percentage of ASs by country that created an ASPA object. RIPE NCC service region average is 3.4%, and we see that actually Estonia and Latvia are above average so far, and Lithuania a little bit below, but these are just the initial steps, and of course any small actually change will really majorly increase the numbers here. So, and with that, we finish the routing security bit, and then I will do a little bit of opening to IPv6. And actually, it's a topic that you're going to discuss later in the panel that Alex will host. So this is sort of a kind of a conversation starter. And we report IPv6 on two measurements. So first is IPv6 capability. So it calculates the percentage of ASs in each country that announce both v4 and v6 addresses, as well as those that announce only IPv6, compared to those that announce only v4. And this measurement indicates that addresses are being routed, but it doesn't equate the adoption. So it's sort of initial step in your journey. And for the Baltic countries, we see it's around 30 to 50%, with Estonia actually leading in the percentage of, we call them V6 capable ASNs, and in Latvia it's 27%, and also this is the snapshot from last month. So Estonia is leading, and then also this is actually just a screenshot from the previous report we published when we had an event in Southeast Europe. These are actually just to show that the numbers are pretty much similar in the Southeast Europe, with Albania, Greece, Montenegro on top, and then Serbia, Romania, Macedonia lower. But it also, again, percentage and the number of allocated resources is really varies. So that's why we need to individually check each country. So about the adoption, it's not really easy to measure. So we use the external data sets. We use the CDN numbers, so chose Google, Cloudflare, and Facebook as one of the major CDNs. And this is their numbers that they report. And actually here Estonia also leads in terms of the adoption. And then Latvia and Lithuania are a bit more similar in terms of the percentage. This is top 10 countries just rated by Google, and only in the RIPE NCC service region. So I excluded actually Asia, Latin America, and Africa from this list. And we can see France, Germany, Belgium, top 3, but also actually Estonia is in the top 10, which I think is great, great score for the region. And actually that was it. If you have any questions and comments, let me know. Yeah, if you want to discuss further the technologies, of course, you have my colleagues here that are happy to help. But if you want to know more about methodologies we used and our data sets, I'm happy to answer the questions. Where is Vahan? I think we need to... Okay, then I think that's it from me. No questions. And we have your well-deserved coffee break, I think, right? Yeah. Yes?
Do we have any thumbs up for Anastasia? Yes. And we have a coffee break. Please come in some 30 minutes. Please, let's run for coffee break. Now, let's run. Sooner, better. Sooner we go, sooner we'll be back. Welcome back again, and now we have who? We have again Alex! Alex! Hello! And we'll have also the panel, and this panel is about the thing and the resources that we actually don't have anymore. It is limited, and this is called what? IPv4, and then we are moving to where? Fantastic, you have socks. IPv6 panel with Alex, by Alex, and for Alex. Not for Alex, for you.
Yeah.
Invite everybody.
One second. Actually, I'm a bit surprised. Vahan is usually such an optimistic guy, and today he broke this rule and announced that IPv6, the number of IPv6 is limited, and probably they are going to be exhausted soon. Actually, probably he knows a little bit more than me about that, because I thought that we have plenty of IPv6 yet. But okay, right now we will have a free discussion, a panel discussion with 3 participants. Unfortunately, my colleague from another Latvian company, LMT, was not able to join us. You know, sometimes it happens. But we still have 3 participants. I ask you to take your seats on the stage, and we will have this. Yeah, please. We will have this small discussion. It's not that, you know, formal panel we have at the beginning, nothing too official, nothing too posh. We are just talking. So that means that if anyone in the room wants to add something, or or to maybe, by the way, maybe ask question, or maybe correct someone, please don't hesitate. Your hand, and we will give you an opportunity to, you know, to participate in our discussion. And well, probably we will start from a small introduction. I will not introduce myself because probably you remember me. If not, that's not an issue. I am not the main participant here, but let our participants introduce themselves.
Hello, I'm Alex Pavlov from Livas Telecom, and in terms of today's discussion, we started IPv6 deployment like 6 years ago. And now we have pretty much everything on infrastructure and running on dual stack. It means both IPv4 and IPv6. That's word for next colleague.
Thank you. My name is Ervin Zgailish. I'm from Circle K. And we are kind of looking for potential directions for the next 3 to 5 years. So our network is growing all the time, so we are kind of forced to consider IPv6. Currently, we do not have IPv6.
And Ties de Kok from RIPE NCC was sitting here as a software engineer and IPv6 user basically since I started in university, and I can show the angle of when I need to think about IPv6 and when it just works.
Yeah, perfect, exactly. I try to gather different participants from different parts of our industry. And once again, if someone wants to add something during the following discussion, please do not hesitate. And so the first question to be discussed, IPv6. For you now, it's just a part of your business as usual, or it's some partial capability, or some future, but clear future you're going to have, or it's something nice to know, but probably one day no one knows when. What is this for you in terms of your business?
Well, yeah, the good question. First of all, what I see in the statistics for Latvia, for example, and it looks like all the operators and providers here, we have a very, very low problem with IPv6 exhaustion. So many of us have enough IPv4 that doesn't make the hard push for IPv6 deployment. Well, in my opinion, maybe it's fine if you have IPv4, you have enough space, yeah, you can work. But anyway, if we walk outside the street, we don't see any more horses going on the street because it's 2026, we all on the cars. And the same for IPv6, it's already time to deploy and start support this in your infrastructure and start providing to the world, maybe starting from your core services, like you have web servers, DNSs, other servers which is exposed to the world, start providing them with dual stack, with dual IP addresses, so the internet can access your services on both types of requests. That's what I think.
And what about you? You said that you don't have IPv6 in production yet, but your plans, you are going to use them soon. You have some clear plans, or it's something purely theoretical for you, or something even not a theory, it's something you don't need at all.
Currently, let's say, we're using, as I said, IPv4, and everything works, right? So from IPv6 perspective, it's kind of a bit of a chicken and egg problem, right? There's no IPv6 specific resources, so we do not need IPv6. We don't use IPv6, there are no resources.
Okay, so, fair enough.
But no, for us, the need is kind of really real and really physical, meaning that our internal network will be so big that we will just exhaust private IP address space.
Okay.
Right. So, and that means I have to somehow make a network, keep the network alive.
Okay, that's respectful.
So yeah, I have to think of something.
Yeah.
On the other hand, and yeah, I have to think of something, and I know the implementation will take some years, so I have to start thinking early. So on the other hand, the constant fight is kind of with legacy technologies we have already in our network. Some metering devices, some signage controllers, things like that. And at the moment, kind of, yeah, we're just looking at potential somehow how to keep both stacks alive. Maybe transport over V6, endpoints over V4, and kind of mishmash of everything.
I see. By the way, actually, we are discussing these aspects. That's well, probably not for participants, but for everybody in the room. We had our training course, maybe the first part of IPv6 training, but we have exactly this discussion, how to, to implement IPv4 only on your infrastructure, how to deal with IPv6 only in your infrastructure, IPv4, how to deal with IPv4 on your edges, in your customers' networks and everything. We have the next course, Advanced IPv6, so if someone is interested in, please check our schedule of our training courses. We will be happy to discuss it with you in technical terms, not like in light discussion we have today. And we have also Thies, who is my colleague, so I'm not going to ask him about our business, but still you have everyday activities, you are doing something. When you do something, do you use IPv4 or IPv6 for internal purposes?
Internally, we use
for yourself,
For myself, internally everything is dual stack, and you do not have to think about it at all until something breaks. And when something breaks, the dual stack is extremely annoying because it introduces a lot of ways where it can break. And the network and routing is something that used to be hidden from software, from developers, but with containers and with DevOps, this got closer. So we see a lot of failures that, like, it's not always DNS. It's like always DNS or IPv6, and then you start looking at the rest.
Basically, looks like these nice dual stack mechanisms are hiding issues until it's too late. Do I understand right?
The dual stack setup in combination with happy eyeballs, so you prefer the connection that works. It hides issues, and then if your access layer, like if your mobile phone provider does not have IPv6, but you want to access IPv6 only resources that are on a VPN, it becomes complicated, and you have to be aware of all these things. So yes, I would prefer transition or v6 only by now.
Okay, fair enough. And your pressure is understandable. What about you, colleagues? What was the main reason? I've heard that, I heard you, I mean, that the idea behind implementing IPv6 was not to, basically to use push words, not to have some technical depth in future. Because, technology is here, it's developing, there will be the major development, major technology one day, so it's better to start earlier to, you know, to have experience. Do you understand that this was basically the only reason, or you had something else pushing you towards IPv6? I don't know, the client's demand, or I don't know, security aspects or something.
Yes, some customers can request from your IPv6 subnet. Yeah, in this case, you need to provide all the paths from your BGP connection to your core routers, to your servers, to your DNS records, to everything, and down to the customer to make this properly work. Yeah, and now when we today, it's quite good implementation on almost every equipment vendor of IPv6. Back like 10 years ago, there was a huge problem for many companies, operators, because they have switches, routers, etc., which are quite older models, older technology, which is not supporting IPv6, or was just IPv6 ready, which is nothing. It doesn't mean it will work, and you should also understand that for us as a society and humanity, we're using IPv4 for a long time.
Yeah.
And also the engineers of equipment like Cisco, Juniper, any other, MikroTik, etc., you name it, they debugging this IPv4 stack in the hardware, in the software. They debugging for last 30 or 40 years already, making routing more faster, more efficient, less errors, less failures, etc. But in the IPv6, many of the vendors just started this process 10 years ago, implementing good support of IPv6 in the hardware. It was the issue for many operators like 10 years back, but now you can feel more or less safe, take any modern equipment and start deploying IPv6 from it.
I see.
Okay.
And you?
Yeah, I would agree that IPv6 implementation now is quite robust. So yeah, I think now is the moment basically to start looking and seriously considering if you haven't done it already. But I would say that the pressure on the service provider is quite different than the pressure on the enterprise.
That's why I try to gather different people.
So as an enterprise, right, I'm expecting my provider to do everything. Meaning I want IPv4 traffic, give me IPv4. I want IPv6 traffic, give me IPv6. I want, I don't know, I want a wire from point A to point B, give me the wire, right? So on one hand, if we kind of focus more on the transition to IPv6, for the enterprise, it's kind of at the same time easier and more difficult, meaning that I have my business side applications that can tie me down as well as hardware, right? So I have a legacy stuff that I just have to use it. Business continuity. From that point, it's difficult.
Yep.
From looking at the opposite side, it is quite easy because I can hide my inside network from outside. And if I'm looking from the outside, it almost doesn't matter what it is. Meaning I can be on the outside IPv4, I can be on the outside IPv6. As long outside is outside, I'm happy, and that's it. And that hiding kind of alleviates the pressure from the IPv4 size as well, because I don't have to have a big subnet. I can have something small, /28, /29, and I'm happy. As long as I'm not publishing too much outside or exposing myself too much outside, it's fine. And I'm probably just guessing, but kind of transitioning, I believe, from the service provider perspective is a bit, again, twofold, easy and difficult. Meaning that if we go back to requirements, if the customer asks for a wire, it doesn't matter what kind of IP addressing it is. Protocol doesn't matter. It might not be IP even, right? So you just do your MPLS stuff, transport frames from one side to another one, and that's it. Everybody's happy.
Yeah, basically, yeah.
If we talk about IPv4 or IPv6, then I would say, yeah, just the same. You could treat your own network as a client, and you can do it block by block, basically. So if you have your web server farm, from the network guy's perspective, it's just another client. It's just an, okay, it's same autonomous system, probably. Maybe internally not. So trying to, but in essence, that's another client for your network. So from service provider, your MPLS could run IPv4 and you transport IPv6. It's MPLS, everything works.
Yeah, that's true. Unfortunately, we don't have our colleague from the mobile operator, so I will share my experience because I spoke to many mobile operators. Actually, what you told is completely 100% true for transit providers. No matter which traffic I'm sending, that's so easy. So that's why we had IPv6 on backbones back then in 2015 already. All large transit operators did IPv6. You need this, take this. No issue. With edge providers, it's a little bit more difficult because they are using addresses themselves or they are giving addresses to clients. And of course, there is a lack of IPv4s, so they are using private networks, which means net devices, and their net devices are a bit different. They are quite expensive because they have to be powerful, and you need to improve and improve and improve them. Basically, it means that you pay for them every single year. You have this row in your budget, specific row, extending your CGNet farm. And IPv6 helped with that a lot. I will share with you some internal story. When I just came to RIPE NCC, it was 2016. My colleague, he's working to other organization these days. My colleague had a request from our member, from engineers from our member, please help us to provide the return of investment model for IPv6. We are mobile operators from Switzerland. No names again, but it doesn't matter. And he helped them to build this model, and they were extremely happy. They went to the management, and they were extremely happy up to this point. They presented results to the management, and instead of some nice words and everything, management said, with this ROI, why it's not here yet? That's true story. they had to explain that, well, you know, we had, but for them, that's a real thing. The CGNet is completely different from, you know, like fixed line, small fixed line operators have, or enterprises have. The CGNet for them, it's extremely important thing. That's why mobile operators everywhere in the world start implementing IPv6 first, just to augment this the picture we are discussing, because unfortunately, my colleague is not here, and he's not able to do it himself. And by the way, you also covered a part of the next question, so I have the question to other participants. You said that this is easy and this is not that easy. What is the hardest part for you guys in IPv6? What is the obstacle? You know, that's the processes, or well, we found out that technology are mature enough, but maybe some technological issues, or customers, users, or what? What is the hardest part of IPv6 from your perspective?
First of all, the IPv6, if you're a long time and familiar with IPv4 and you start IPv6 deployment, it requires a little bit rebuild, change your thinking of how you're doing all the networking and how you're planning this, because it was in IPv4, if you're planning to deploy 12 servers, you will probably not give it /24 subnet. But in IPv6, it's quite normal to deploy to the customer, to the data centers, to all your routers infrastructure, quite big subnets. This is the concept. Also, if you're doing some NAT translation in IPv4 and IPv6, you don't need it anymore. So you have enough IP addresses, but you need to plan up front to give a bigger subnet, even if you think it's for 12 servers, maybe you need much, much smaller. But anyway, you're giving the bigger, as it's described also in the RIPE documentation. There's a quite nice information about that, how you should plan your deployment, how you should draw it first, then start. So yeah, the first problem was is planning and rethinking the concept that it's different from IPv4, and you need to start from the beginning to do it in the right way, and because you don't want to change everything later. Yeah, so this maybe was the hardest task, and all other just technical implementation. If your equipment supports it, you can do it. And that's what.
Yeah, looks like. Correct me if I'm wrong, but it looks like you had two large parts. First, this planning itself, preparing everything thoroughly to have everything covered, and the second hard part was is that IPv6, it's like same but different.
Yeah.
Yeah, that's a good observation. Thank you so much, because well, probably the first time I have it stated, actually. But yeah, that's a valid point. Thank you.
Okay.
It is for you.
And there's two things. I think the thing about numbering was a really good one, because you need to completely, coming from IPv4 world, it feels like an unreasonable amount of addresses. Every virtual network you have on every host is a 64. Every host can have multiple networks on it. It just adds up and it adds up. But what is hard is that it's the lack of knowledge about the details, because you will hit bugs, and the bug that you will hit will be something with
a lost array advertisement somewhere in the network between switches, etc., and load balancing going wrong. So when it breaks, you hit, sometime your point was kind of right about the bugs that are got in IPv4 that you can still hit in IPv6, and then you need to understand all the stack. But there's parts that with IPv4 you always need to look at. Like you need to look at the DHCP. You need to touch it every time you configure a network. And with IPv6 it just works until it does not. So it's like when you do something every month, you know it well, you get to understand it. But with IPv6 these details are not familiar enough for me. It's my own mistake maybe, but yeah.
Okay. I told you that's important to have different people.
And also, yeah, one interesting fact that when you draw everything, all your routers on the map, all your VLANs and everything, planning how you distribute your routes, and then you start realizing that you are in a nightmare. Because
nightmare?
Yeah, because in everyday life, if you need, for example, to ping something, yeah, it's in IPv4, it's 4 octets. And if you're long in the business, you can remember it, and you can do many manipulations with this IP address. And in IPv6, it's very long and ugly numbers, which is really the problem to remember and mistype very easily. And if you want to ping some IPv6 address without a compression, it's very long and horrible. Really, it makes your life much harder than it was with IPv4.
Yes.
Then in some second stage, you start understanding, yeah, I planned everything right, but something is wrong. I cannot operate this network. So then you start thinking how you make this IP address as a beautiful and a short way to, for example, match some digits, match your IPv4 and IPv6. So you easily remember, and even if you query from DNS, it will look quite similar IPv4, IPv6. So this is the second stage when you make really your life easier and IPv6 numbering beautiful. Yeah,
I understand. Well, actually, from my perspective, I know what you mean, and these long numbers are not that easy to remember. But you know what I tried for myself. Oh, I did it, you know, for my internal network in my house. So it's not that big, but still, you are spotting that the beginning is always the same. I could skip it, and you know this part means that room. This part is here. This part is here. So you know you spot it piece by piece. And that's exactly what you're describing. But I do it. I did it probably, you know, intuitively, but exactly the same. And probably that's a good practice, because otherwise, yeah. First, I started distributing, you know, this address from my house. It was exactly what you said, nightmare. What is that? What is that? What is this? And when you have some system, it starts being understood easily, really easily. But but you have to be used to this. Yeah. So yeah, I agree. That's a good comment, right? Thank you. And by the way, I mentioned that if someone in the audience has something to say, maybe you have your experience to share. We have, well, yeah, we are 2 minutes ahead of the schedule, so we have 2 minutes. If someone wants to share, no, everybody is so passive. Okay.
But do we even know who's using IPv6 here? How available is it for the people in the room? Because
Oh, yeah. Let's ask the first question, by the way. How many of you guys are using IPv6 in your networks? Well, we have some, yeah. I would say at least, well, dozen. No, more, almost 15 hands. I saw them. Well, it's not that bad. And
but the difficult question is, now you've adopted IPv6, you've given your devices IPv6 numbers. How many people do have IPv6 on all the connections that they use during a working day? Like on mobile, in the office, at home? How many of you have it everywhere?
I saw one hand. Anyone else? Yeah, send 3. Well, Vahan, we need your socks. We need your socks.
I would actually ask a different question. Of those people who use IPv6, how many of you don't use IPv4? I think if somebody raises a hand, that needs at least 2 pairs of socks.
Yeah. But probably that's why this guy is the member of our executive board.
I think we should split the pair of socks. One guy gets right sock, and the other left.
Before MV6.
The meter and the tags. Yeah. Who wants the meter? Who should I give the meter? And who should I give the tag?
So, well, this guy, the second in the second row. Yeah. I don't know. It's up to him.
Do you want to meter or do you want to
And we had extra 2 hands over there. Guys, could you please indicate yourself? Don't be that shy. It's not dangerous to get this tag. It's a usual spy equipment. It's nothing special. And someone else raised the hand, but not... Okay. You will live without MPLS and tagging. So the next question, when it comes to this stage, which arguments worked inside the organization? When you started that, you had to convince other people in the organization to cooperate. Otherwise, you would do nothing. So which arguments were fine on slides, but didn't work in real life? And which argument did the job?
Yeah, the first argument that we soon run out of IPv4 space. Well, however, it can take a quite long time or maybe short time. You don't know at the moment. Mm-hmm. But it will happen anyway, and you will need more IP addresses, and the only option is to use IPv6.
Okay.
That's the first.
And it worked. People just answered, okay, we understand. It's necessary to do it right now. Not like, well, probably tomorrow or one day or something.
Well, it's what I can say. It's not doing in one day. Yeah, there's the preparation and all the servers, everything. You're analyzing all the equipment. Does it really support or not support? Will it work? All your servers in the software, does it support IPv6 or IPv4 only? So it is not possible to do it in 1 hour, 1 day. Yeah, it's quite long process, and sometimes even you already deployed, but you found that still one server missed and not configured IPv6, yeah. And then you adding it in your infrastructure. And the most, of course, tricky part is the financial part. So if you need to invest in new equipment, then you should clearly understand how much and what equipment should be changed.
Yes.
And
And
then
you have to convince your finance guys, right?
yeah, in my case, I don't need to convince myself. I'm a company CTO. Yeah, so I myself, I understand that we need to do something to go forward this way. And if we start today, then in 1 or 2 years, we will have the positive results in this deployment. So that's my opinion.
Fair enough. What about you in your organization? Probably your case is different because you are not the foundational guys.
For me, kind of convincing the business side that we need this is really, I don't think it's really a problem, because we just say, yeah, technical requirement. Right? So if you run out of IP space, you run out of IP space. It doesn't matter what it is, you run out of resource. You have to switch to another one.
That's an important lesson to learn, you know, for everybody. Thank you for sharing.
Yeah, the hardware aspect of it kind of applies and kind of don't. I mentioned the legacy systems, so that's obviously new hardware, right? So there is a cost in that. Yeah. If I can leave that on IPv4 and run dual stack, then I can alleviate that. From the networking equipment, maybe I'm lucky, but because it's kind of a bigger enterprise, so you typically live on something like 5-7 year hardware cycle anyway, because manufacturers just send support for them. And you phase out all the equipment. And nowadays, most of the equipment is dual stack already, so there might be something, but I don't foresee anything big that needs to be purchased, like core routers, core switches, things like that.
I would say that this story is quite typical. I've heard it many times, that we thought that we will have to switch a lot of things, and you know, maybe our equipment does not support it. We checked and everything works. We just didn't check before. We didn't know that it's that easy in terms of the support. These days, it's really not an issue. It was back then.
Yeah, when they switched over, probably it was really an issue.
Yeah, but some people are still thinking, you know, these days, and yeah, that's a good point to share. Tiz, what about you? Did you have any issues with IPv6 with your colleagues? We have the management team here, so no names, please.
No, there's the idea that we always have IPv6 on things, and that's a principle. But if you go up the stack, sometimes these principles become very hard, because when you are looking at vendors, not for the network or for generic components, but for specific services, IPv6 may become the criterion that causes you to need to choose one vendor or the other, and becomes sometimes can have a very big impact. And I see that's where we sometimes make a compromise. Now, you mentioned IPv6 only. If you ever make the compromise on having not having IPv6 everywhere, and somebody also decided to do IPv6 only somewhere, that's a very painful world that you've created.
I see. A good point as well. Yeah, thank you so much. Please go ahead.
So, kind of, if we maybe revert back to transition, right? So, I foresee the biggest problem would be actually procedures. Nothing hardware related or nothing software related. Meaning that for every problem that you have your, I don't know, legacy box ABC. You can find and replace it. That's a finite problem. You have it, you solve it, you're done. You need to reconfigure your devices. You do it, you're done. But as colleague mentioned, support procedures, that's ongoing problem. Right?
Okay.
And if you have a larger network, you have to automate. So your automation procedures. So the biggest problem is actually do all those procedures, redo everything from scratch, including new troubleshooting techniques, new troubleshooting guides, new training for people who do troubleshooting, who do installations. So that I kind of foresee as a biggest problem, and a kind of problem that could be solved to the best part, probably in finite time, but it's an indefinite thing that happens all the time.
I see.
Is that a cost that exists because you will always be in, you think you will always be in transition between IPv4 and IPv6?
Probably, because applications migrate, right?
Yeah.
So things always change, so you're always kind of transitioning.
Yeah. So you will have this cost until the long tail. We had a situation where a tiny bit of the tiny bit was on IPv6, and that was causing the problems. And in the transition, at the end of the transition, you have a long tail of the few final V4 devices that caused.
Yeah, exactly. And until I can't get rid of them, it means I still have to maintain both worlds. Kind of that I think will be the biggest one. The kind of aspect to all of that is actually control. Again, somewhat tied to procedure, somewhat tied to design itself. So with IPv6, quite a lot of things are automatic. So in my particular case, automatic, it's fine, but to the point. Right? And I want to maintain control which devices I allow into the network, which ones I don't. Some IP addresses, for example, have procedurally special meaning, like some particular device is always IP address, I don't know, 15 or something. So I have to maintain that. And because, again, of IPv6, it's longer, it's more difficult to handle manually. I mean, digit form, right? I don't know who can multiply in hexadecimal here. Probably nobody, right? So in their head, right? So you need to calculate, you need to adjust to that. And that kind of brings another tie-in into different services. So, okay, everybody can ping and type IP address, IPv4 IP address. It's difficult to type IPv6. You don't want to type IPv6.
Right.
You want to use name. But if you want to use name, that ties into DNS. What happens if your particular branch is not reachable at that point? Where do you put DNS? So if you put DNS locally, you probably can guess how many fuel tanks we have in Europe. So imagine that maintaining that many DNS servers, synchronization and so on. So kind of, again, it ties mostly not to technical things, but to processes, either automated or manual.
Yeah, perfect. Basically, what I've heard, you either go for IPv6 or for anarchism. You can't have both.
You can, but you have you have double the trouble.
Yeah. No, operationally, you can't actually. Theoretically, yeah, but we are almost finishing, and I have the last question for you. We know about IPv6 that in IPv6 already we have some capabilities and technologies which do not exist in IPv4 because we have more bits, we have all these fancy extension headers and everything. But that's theory. Maybe in your experience, you find, well, you already have found some things which are specific for IPv6, which helps you a lot, which did not exist in IPv4. Your specific experience, maybe something small, but still something in IPv6 which makes your life better. And the development of this question, imagine that IPv4 never existed. What would be done completely different now in your organization? What would be what would look completely different and maybe better?
You would have the networks next to each other and not in each other.
Sorry, come again?
The numbering scheme would look completely different because you have the space. You don't need to. You have something that can look way more uniform, so it's easier to think about.
Okay, fair point.
I already mentioned that the NAT is commonly used in IPv4. I don't think it's a big problem if it's your home router, yeah. But it becomes really the bad solution if you have many customers hiding over the NAT. Translation technology, and IPv6 doesn't require these things to do. So it's more direct way for every device, every customer to reach the internet with their own unique IP address. That's one of the difference. And what you also told before, the load balancing is easier.
That would be discussed, yeah.
Yeah, on IPv6 rather than IPv4.
Well, we discussed it a couple of days before, so you didn't miss it today. Okay, yeah, fair enough. And what about you? Maybe.
So if there was no IPv4 and we would
first of all, do you have something with IPv6 which, well, maybe in mind? Maybe you are going.
If you're deploying just in your lab or a closed environment, you can do just power up a couple of servers or a couple of machines, and they automatically get IP addresses. You don't need manually or DHCP to assign. You get immediately access by IPv6 from one machine to another, so because it's
saving time.
Yeah, it's saving time in your lab or LAN network. Yeah. Because of this local addresses automatically generated, and you don't need manually to log into your machine, put it manually your IP address and configure. Yeah, it saves time in this scenario.
Yeah, when it's appropriate, you can use it.
Yeah.
That's true. And the maybe small tips, small things with IPv6. Which makes your life easier in comparison with IPv4. And the larger question, what would be completely different if IPv6 never existed?
From the end user perspective, I would say yes.
Up to you.
The best
Any
thing
perspective.
Yeah, from end user, the best thing is really you just connect some computers with the cable, and that's it. They talk to each other. From network perspective, absolutely fine. Probably, I think there's a bit of lack on the application level to support that. But end user perspective, ideal.
Okay.
Right? That obviously creates nightmare for the networking guy, but yeah, you can have everything. What if IPv4 didn't exist and we got straight to IPv4?
Yeah. What would be completely different, if any? Not necessarily, but maybe.
To be honest, my first thought was, hey, we would have such a free and nice world, right? No configuration, just plug in your device, everything works. You want your typical dream, right? Connect your fridge to the network, and you're done, right? Plug the cable, and that's it. Yeah, that's on layer 8, right? On the IP stack. But that's still a dream, right? So and if we go down to more like realistic expectations, I would say we would probably end up kind of the same, because I think the current restrictions on the network actually do not come from the network. Current restrictions on the network come from the application side, but even more restrictions come from security side. Right, and people like to be secure, right? Even if I had, I don't know, IPv8 or whatever, right, in my home, right? So I have my magical box that gives me network. I would still like to protect it. So there would be some kind of mechanism how to hide my internal network from the outside.
Yeah, I agree. If anything to add, it will be the last words for this panel.
No.
Okay, so I will thank you so much. I think that it was nice and, easy discussion. I didn't make you too tired.
Yeah, hope nobody is sleep during our discussion.
Looks like nobody is sleeping. Well,
Not everybody listening, but nobody is sleeping. It's a good result.
That's a good balance. I agree. Thank you so much.
Thank you.
Let me summon my colleague Vahan to continue. Thank you.
I don't know if I need this microphone. Thank you, and we have now what? Lunch? Aren't you hungry? It is not lunch. It is lunch. Nom nom. So we are going now to have a lunch. Okay, and we are back after lunch here. In how many minutes? In 1.5 hours, I guess. Yeah. So welcome back here so you can see myself as a speaker. And finally, we are back from really good lunch. Who has enjoyed it? You enjoyed it. You enjoyed it here? Yeah, that's nice. That's nice. Yeah, I also enjoyed it. And before I start, I want to just remind me about the last opportunity for you today till 3 p.m. So last 29 minutes to get registered for the Certified Professionals exam. We already have some, I guess, 9 to 10 people that have registered for them. A huge part of them have already passed. But if you want to take this exam, just go to the registration and get registered for these exams. This is a really exceptional opportunity because we do provide this exam opportunity right here. Next time, I guess it will be at RIPE meeting next year in Vilnius. So if you want, you can just try. It is quite interesting. Can you please put my presentation? I will be presenting this time. I'll not calling anybody. Yes. So this is the capacity building with RIPE NCC Academy. What is RIPE NCC Academy? This is, let's say, a domain where we have concentrated all our capacity building tools, or almost all our capacity building tools. So we have a lot of instruments there. So first, slide, or first we will discuss what is this RIPE NCC Academy itself. We will also discuss which topics do we offer, so where are the areas that we provide this support, how this all academy works, why to learn and how to get certified in this academy, and this is the option that we are providing today. We will talk about some regional training statistics and the information for this, let's say, region. And we will also talk about what is new in this academy. So what is it? What is the RIPE NCC Academy? What do you think? What is this RIPE NCC Academy? Who are the graduates of this academy? Are they academics? What do you think? Are they? No? They are not academics? No? Nope? Nope? No, they are not academics. They are simple people as we are. And this is just one-stop shop for learning and getting certified. So it is not only about taking the exams. It is also about learning. We're providing the knowledge, and we're certifying that you have got this knowledge and you know what you are passing. It is overall 190 plus hours of learning in the academy. You can take different courses. You can take different opportunities. It is not obligatory to take them all. Whatever you want to take, you can go there, see there, and take it. We are doing it, in fact, for more than 30 plus years. From the beginning of our organization, we are providing and we are trying to build the capacity of technical community, because we believe that if you want to make the change, you should know how to make this change. If we ask them, if we tell that we should move to IPv6, we should implement RPKI, we should also provide this knowledge to them. They should know how to move this to this IPv6, how to implement this RPKI, how to make the good BGP regulations and all this stuff. Can you imagine that we have trained 67,000 participants? I cannot imagine this number. Just imagine 67,000 people, 67,000 engineers, 67,000 professionals that can do their work perfectly, or at least they have got this knowledge and they can do it now. If you go to the ratings that we have got from all these trainings, it is 4.7 out of 5 for our e-learning modules, but we have also in-person modules. So which topics do we offer? What is the fields that you can get this capacity building? We have several. We have the IPv6, obviously. We have routing, obviously. We have measurements and tools. So you can make the measurements in your organization, in your country, between the regions, in the world, and all over the world. We have, this is one of the last topics we have included just recently. This is the internet governance, because internet governance in our, let's say, industry and in our world is going more and more important and more crazy sometimes. So we are also proposing this topic as well. And we have actually the internet registry. How do we work with internet registry? What you can anticipate from internet registry? How to work with them? What to get from them? And what to offer them? We have several levels of these topics. One of it is fundamentals. Another one is advanced. And we have the expert level as well. So for IPv6, we have 3. IPv6 fundamentals, IPv6 advanced, and IPv6 expert. It is kind of academic in IPv6. If you see the IPv6 expert person, so you can tell him, you're honest, buddy. You're the top. So for routing, we have the routing fundamentals, routing advanced. For measurement and tools, we have only these two levels. Internet governance, we have again these two levels, fundamentals and advanced. And for internet registry, we have also two levels. Some examples for IPv6 for fundamentals. We have the e-learning course. As I mentioned, we have different products and that are complementary to each other. We have IPv6 fundamentals e-learning course, but we have also the certification exam on IPv6 fundamentals. So we are not asking you to go and pass the exam, although many of you can do that. Before that, we are providing this knowledge. We have also the in-person course, and many of you can benefit from them when we are coming to this country. We have the webinars as well. So this is the introduction to IPv6 and IPv6 in the RIPE database. For the more advanced course, we have IPv6 Advanced, so the same e-learning course, certification exam coming soon. We have in-person course and also webinars. The same is for IPv6 Expert. So we have the e-learning, certification exam, in-person course, but we have also 3 types of webinars: basic IPv6 protocol security, IPv6 security myths, filtering and tips, and IPv6 associated protocols and security. So different aspects of IPv6, in fact, for really expert level. And you can add there your feedback also, because this is also the webinar. If you want to see all learning paths, you can just scan this. The presentation itself will be also available later. So if you don't have time to scan this now, you can get it in future. You can download it and go to this learning paths. How this RIPE NCC Academy works. So this is part of the RIPE community and RIPE NCC members, although we say that RIPE NCC members is also part of RIPE community. So if you can go there for IP and ASN, LIR portal and general meetings, we are more concentrated on RIPE NCC members. For RIPE NCC Academy, RPKI, RIPE Database, and RIPE Atlas, it is 50-50. Might be interesting for RIPE community as a whole, and partly 50% can be interesting for RIPE NCC members. For RIPE Labs, RIPE Stat, KIRU, DNS, RIPE meetings, and regional meetings, we also engage a lot the RIPE community. Oops, yeah. So what can, who can do what in the academy? So as I mentioned, we have in-person courses, webinars, e-learning courses, certification exams. As we get the funding from our members, we're trying to provide them the most of the value, because they are not only giving us the money, but they are the core of implementers of what we see in the telecommunication field. So we are dedicating in-person courses to the members. In some rare cases, when we have the places, we can also engage, for example, people from academia, if we still have places, people from the ministry or the regulator, so they can also understand that this is important, how it can be implemented, and why and how they can put it in their strategies and regulations. Webinars are open and free for all. E-learning courses, again, are open and free for all. And certification exams, members have 3 free exams per year. If you need any more, just let's talk so we can understand your needs, we can understand what you are going to do, and maybe we will try to support you in this as well. How it looks like, you can see here. As of now, we gave about 55 trainings this year across approximately 25 destinations. We have provided 600 hours of in-person training per year. And in 2025, we have served 850 plus learners through in-person trainings. And you can see, I don't remember where is it, but it's a quite crowded place. So this is how these trainings takes place. And webinars are 1 to 2 hours, online webinars with live trainer. We deliver, again, 30, 35 webinars per year, and it is almost 600 participants per year. E-learning courses, currently we have 138 self-paced e-learning modules. They are quite interactive. If you go there, you will not be bored. We have questions, videos, images, and text. We include the interactive lab, activities in a virtual lab environment, and it is quite interesting. Plus, minus 2,400 modules completion per year. So we have quite a huge number of people coming there and taking that. And today we will have also some statistics on the certified professionals exam that took place here. And it is quite a good statistics, but per year we have around 5,500 exams taken all the time, not per year. And 3,605 plus passed these exams, but it is for all the years. They instantly get digital badges. They can show it in their LinkedIn profile. They can, and these qualifications are quite important and useful and valuable because, for example, if you say that this is the BGP security or IPv6 expert, so it is usable in all the world, not only at RIPE NCC region. It's not only about the Latvia or Lithuania or Estonia or Amsterdam or Netherlands or Armenia. This is really valuable for all the operators in the world. And if you have this recognition, you can use it in all your future career. Why learn and get certified in this academy? So you are instructed on best practices. You are getting the practical knowledge from the source itself. You are contributing to more secure, stable, resilient, and innovative internet. This is general words, but we should understand that whatever we do for the good of people, for the good of internet, for good of us, of course, but this is also the good of the good. Something that is not a crime that you cannot be proud of. This is what we do good things. And you can also, this can be also helpful for your future career development. High quality context, high quality content, a lot of information that is coming from the source. And that is not vendor related. This is vendor neutral information, vendor neutral course, so you can use it with all the vendors. So we have some regional training statistics and the information as well. So in previous in-person courses from 2023 onwards, we had 5 in-person courses in Estonia with 86 participants, with the topics on RIPE database, BGP security, LIR, and IPv6 security. Latvia, we had 4 courses with a total 28 participants. We had IPv6 advanced, IPv6 security, BGP security, and IPv6 fundamentals. And Lithuania, we had just 2 courses with total 26 participants with the topics on IPv6 advanced and IPv6 security. We have some upcoming training courses in August 2026, so you can get registered to Vilnius. Yeah, you can take it from the next, from the presentation itself, or you can make a screen now. And if you see this RIPE NCC Academy certification exams passed per country, just remember this number, because at the end of today, you will have the number from today. So we had 13 exams in Estonia, 24 exams in Latvia, and 45 exams in Lithuania. And you can take, for sure, the free exam. What is new in the Academy? I'll be very fast. The new RIPE NCC Academy website, webpage, we have launched it in May 2026. We bring all the modalities together. So in-person courses, webinars, e-learning, exams, and our topic is quite, our approach is quite universal. This should be topics first. And you can find whatever you need based on the topic and level. For example, if you are going to the IPv6, all the IPv6 related activities will be there. Yeah, and again about the IPv6 advanced course, you can learn to design an IPv6 infrastructure to help deploy IPv6 across various network types. Should it be a small operator or large operator, you can get this benefit of taking this knowledge from there. And also coming this year, we will have a new certification exam on IPv6 Advanced. So, and the new segment routing also V6 lab. I'm quite finished. If you have any questions, you can approach my colleagues at Academy RipeNet. And again, you still have some 12 minutes to go and get registered for the certified professional exam. That's it? You liked it? No? Yeah? Thank you. So who wants to go and get certified? Any new person? You? No? I don't see your eyes. Who wants? You wants to get certified? Okay. Yeah, really? Ulka.
Hi, I just want to add a quick note here saying if you don't feel prepared to take the exam yet, you could leave your name and email with us and we could send you a voucher code. We did lots of research on this. It's like a chicken and egg situation. Mm-hmm. Does the learning cause people to take the exams, or do the exams cause the learning? We came to the conclusion that the egg causes the chicken. It's the exams often, committing to taking the exam often leads to the learning. So if you feel like you'd like to get certified, but you're not ready to do it now, you can always request vouchers and we'll send them to you. Thank you.
Actually, thank you, Ulka. Actually, there are some other goodies we have for the people that are passing these exams. We have some. It's not a T-shirt, right? It is a hoodie. It's a hoodie we have. Yeah, we had it. Yeah,
we had. T-shirt might be a hoodie.
Yeah, but I have some goodies, hoodies, so I can give it to really good people that are passing these exams, and. You know, we also like to hear your feedback. What do you need? Because actually we are doing these exams, we're creating this content, but maybe there is something, and we were discussing it, I guess Ulka was mentioning it, or Hisham was mentioning it. We have these working groups, and we don't have the AI working group, right? And maybe you want something else out of what we are offering, because you are the members and the community, you are the force that is telling us what we should do and what is the direction of what we are going to do. So tell us if you are interested in any other topics, if you need any other topics, so we can understand it from your contribution and try to design our programs based on that. What else do you want to have? Not only about the certified professionals, not about the certification. What you need from the capacity building? Do you need anything else? Huh? What do you need? Because the same, we are the organization that is your hands, in fact. Accept us as people that work for you. You have one department. There are people working from Amsterdam, people working from Armenia, people working from Dubai. I have counted yesterday, and it was around 10 languages we can speak now today. With this stuff that is present here, we can speak Arabic, we can speak Russian, Ukrainian, German, French, Armenian. I can speak Armenian if you want. I guess you don't want? No? Çek uzun? Կուզեք ես հայերեն էլ խոսամ։ Հայերեն ոչ մեկ չգիտի, չէ? No, unfortunately. No, nobody knows Armenian. Okay. Okay, I will start talking about that as well in Armenian. So you can approach us, and that is why this RIPE NCC is an organization that works all over the service region for the good of all of us. So you can approach us with any question. Is it about the internet development? Is it about the technical internet development or any other question? Even if it is not in our mandate, we can just redirect you to people and organizations that are implementing these activities. We have partners from different organizations, and we have some MOUs with industrial organizations as well. We have people, for example, from Nog Alliance here, yeah? So they are doing also some good things. We have a lot of activities with ICANN, with ISOC, with others and others. Romain was talking about the activities with the EU we are doing. So please use these routes, please use this capacity to share your thoughts. What should we do? What is very important for you? What can we do for you? Should it be the trainings, capacity building, policy development, advocacy, lobbying? Tell us and we'll make it, especially Romain, if it is EU. Okay, so thanks a lot. If you don't have any questions, we can go for the next presentation. Can we? Do you have any other questions? No, you don't. But you can approach me later, I'll be here. And our next presentation is, who is? Yeah, you? Yeah, you? Is it you? Yes, you can do that. Come, please. Yes, yes. Yeah, you can take this. Can you put the next presentation?
Did I upload it? Oh, it's there. Okay, good. So this is my second presentation of the day, which is about RIPEStat, which is another product I work on. And I'll show some nice, some features that we like and some features that we're working on that may actually help you when debugging operational issues or looking for information. So let's start. This morning there was a show of hands. It wasn't as many hands as I had hoped. So we'll do a generic introduction of what RIPEStat is. And RIPEStat is a tool by the RIPE NCC for information about IP addresses and autonomous system numbers, mostly, and also some statistics about countries and host names. And this is all visualized. And all the data that's available in the user interface is also available via an API. So you can either look at the data, you can also inspect how the data is loaded by these widgets, or you can look at the API documentation and use the data yourself. The data we have in there is from a whole collection of data sources. Of course, the routing data that I talked about this morning is a very large part of it, especially volume-wise, it's a very large part of it. And we also have information from various routing registries, because when you're talking about internet routes and what's in there, you want to look at RRR and RPKI. There is DNS information that we store in there, and there is longitudinal statistics over time about the allocations from IANA and the RARs to different organizations. So you can get an overview of how a prefix was used and how it's distributed, was it transferred, etc. So the main use cases we see is looking at routing. I think I was clear about that. Routing security, RPI validation, making sure your RRR records are in place and they match what you are announcing, checking some DNS settings. It has an excellent way to look at network outages when they happen. I'll show some of those features later. You may have heard about BG Play, which is an animation of BGP updates happening over time. And there's another one like that I'll also show. And it has the looking glass. And as I said, this is all available in the website or in the API. So yeah, let's take a look. It is just a website. I think this format is familiar. Search for an IP address for the resource you want to see. So an IP address, an AS number, a country, or a domain name. And there's some autocomplete and some suggestions based on what your IP address is, what you typed in. It kind of matches names. We'll probably make this autocomplete a bit better later in the year, but it's not what we're focused on now. But okay, you search for the resource and you find the basic information there. And then it's grouped in a number of categories. So depending on what you put in, because if it's DNS, if it's a country code, it doesn't make sense to give data about routing. But if you put in an IP address or NAS, you get information about, you get an overview page first, and there's detailed information about routing, DNS, records in the RIPE database, historic transfers, and a little bit on RIPE Atlas. And if you put in the domain name, it will look slightly different, but it's definitely strongest for IP addresses. And now we're going into a number of use cases, and I think I mentioned it this morning, was that this routing data has been collected over a very long period of time, and while you have a feeling for what was happening in your own network, you can probably recall what you were announcing and whether you aggregated or de-aggregated. Doing this for another AS is more difficult, and if you know that space moves between networks, etc., it's even more difficult to get a picture. So we have a feature in there that shows the history of routing for one AS. So you see the prefixes, when they were announced over time and how visible they were. But you can also see that at one time for multiple ASNs. So you can see, for example, okay, this AS was announcing this first, then it popped up there, etc. And you can see when, in this graph, you can really nicely see when somebody de-aggregates, for example. Don't think that happens here, but yeah, but you can see that somebody was announcing space, then they were not announcing it, and then it pops back up. There is some statistics about countries in there, which we kind of need for our own reporting as well, because we like to have numbers for what we're doing. And yeah, we have information about just the resources that are allocated to a country or are announced, the ASNs that are active in a country, RIPE Atlas probes that are connected in a country or were there, and I think also our allocation, the amount of space that was allocated. And again, you can compare this. It's a feature that maybe we like more than you guys do, but we try to build the visualization, and then we try to reuse the visualization in a way that it's useful. If it makes sense to compare it between resources, we build that feature as well, because it comes almost for free. So up till now, it was the stuff that doesn't excite me personally as much as the other stuff. And now I talk about one that's very unique, and depending on what you're looking at, either very confusing or very insightful. And this is BG Play. BG Play is a visualization where you can select a prefix, and it loads, and you can select the prefix and the time range, and it loads all the BGP updates that happened for that prefix in that time range. And then it visualizes the BGP graph. But then it starts playing the time range, and when an announcement or withdrawal happens in that time range, the graph gets updated. And that's how BGP basically works. But what you then end up seeing there is that when an AS path changes, because there is a re-announcement for a prefix, the graph changes. And for some specific problems, some problems that are hard to understand when you see the updates in a text file, they are much easier to understand in this visualization. But this kind of is an expert tool. So it can be very nice. It's kind of a sharp tool, I guess I would say. It may also be very, very confusing. So there's another one that makes it easier, which we will see in a few more slides. So keep in mind that seeing what happens in BGP in BG Play is very detailed and kind of confusing. And at the top here, you see a link to upstream visibility. That will come back later, where you see a much simpler visualization of what's happening in BGP. Because if you see a prefix disappearing from the internet, you slowly see the withdrawals coming in. And so if you look at this graph here, you see, okay, you have this graph of all the ASNs that are connected, are known for this prefix.
it starts being withdrawn, and you see these branches either being cut completely when it's withdrawn and there's no alternative route, but when path hunting happens, you see that the route changes in this graph. And you see that this BGP graph becomes kind of sparse, so there's only a few paths left. Keep that in mind when we come back to upstream visibility, because there you will see the final effect that it has on, on other aspects. Now, at the beginning, I mentioned that we have IRR and RPKI as a data source, and this is something that we use internally a lot when it's used in ARCs, and people say they use it when debugging problems, which is routing consistency, which is one table where you see the announcements you see the prefix, you see prefixes, you see if the prefix is visible on the internet according to RIS, you see if there's a record in IRR for that prefix, and you also see if there's an RPKI VRP validated ROA prefix payload for that prefix. And when there's a VRP, you also see whether it's valid, if it's green, if it's red, if it's invalid, and then it might actually not be visible in RIS. And you also get notified when you make a ROA that allows too much, because if you make a ROA where the max length is longer than what's actually announced, and you don't announce all the covering or specifics like Standard Stefan does, you're open to a hijack. So that's a situation we want for as well. Then this can go one step deeper, where we look at the complete configuration like they would in an assistance registry check, where we don't only look at the routing records, but we also look at the reverse DNS songs and whether the domains reverse DNS server you've set up is set up correctly, is reachable, does V6, and adheres to all the checks that Zonemaster says you need to do for your DNS server. And when you read the list of checks that are automated there, you realize that DNS is actually kind of hard. So even for our own prefix, we didn't score well today because one of our secondary DNS servers wasn't reachable over V6. So that's why AS Quad 3 has a warning for reverse DNS. Then there's a very nice feature of RIPEStat, but it also really highlights the downside, which is the looking glass that we have, which is really, it's a web interface for a looking glass, and it updates almost instantly when BGP announcement happens. The downside of this is that this shows that that this data updates immediately, but for all the other data that we show, it takes a while to be processed because they're batch-based systems. So if you want to look at something that just happened, or you're debugging something, the looking glass is really good. But if we have a chart over time, like where you had the 20 years of data, the data is loaded every 8 hours. So it may show something different. And yeah, that's a place that we're working on. And while updating the data faster is something we're working on. And when talking about the looking glass, this week, we didn't make it before today, we're working on making sure that extended and large communities are displayed correctly, because we just fixed the bug there. And soon we also want to show the description for community, because we saw that in other places and we were wondering why we didn't have that. So yeah, short recap, what is RIPEStat? Is an information service, has information from these servers, from all these different sources, and it's visible in one place. I lost a few slides. I'm sorry, guys, I can try to do a live demo of upstream visibility, but I don't have the slide in the presentation that I thought I had. I'm sorry. I was excited about that one.
No. And now we are moving to somewhere I have heard about this expression. And now we are moving to Oh, Eurovision, right? And now we are moving to Romania. And we are moving to Romania. Eric, please. But the question is, why we don't have applauses? Do we like Romania? Nice. I can give this to you.
Thank you very much, Vahan. Hello, I'm Eric Andrei Boleanu from Interland Internet Exchange, and I will tell you today our story, how we started from some local area networks in Bucharest, and now we have the biggest internet exchange in Romania. So, in the late 90s and early 2000s, many networks in Romania were built by the users themselves. People were used to connect their computers with cables and switches, and they were using these networks not for internet, but for local communication, to exchange files and to chat and to connect with each other. So they were not internet service providers. There were only some local networks built by local communities in order to exchange content. And later, the context was that dial-up connections were expensive, were not permanent. Permanent connections were very expensive, and only big companies could afford to have a permanent connection at that time. And in this context, users on the same network, on the same local area network, started to put money together and to acquire a permanent connection in order to have permanent access to the internet. So these networks became platform for internet access, not only for the local communication. So that these networks, at some point, these networks started to grow, and many of them became small local internet service providers. And at some point, they realized that part of their traffic could be exchanged locally, because they were using their upstream providers, and a lot of content were exchanged between different networks. So they need to interconnect. So instead of sending traffic to their upstream provider, they began to connect their networks to each other. These early connections were informal and were built on practical needs, not on a formal design. So we were, at that time, we were effectively building an internet exchange point without knowing the term. In the early 2000s, around 20 local operators from Bucharest decided to interconnect their networks. This is a photo from that moment. And this initiative became Interland. And the name comes from interconnecting local area networks, which reflects how we started. So we had, as I said before, we had a little understanding of how internet exchanges should operate and should work. So we evolved step by step. Let's look at the context in Romania between 2002 and 2006. We have a growth of internet service provider. So we had over 1,000, and many of these were very small. And very small, and they were originating from their local communities. So this created a very dynamic market and also very fragmented. You can see here a graph from the Romanian regulator showing the number of internet service providers starting 2003. So you can see the peak was in 2006, and then we have slowly decrease. And now it's the drop is almost 80% of the comparing to the peak years. So today the market is very concentrated in Romania. We have top 3 operators that control more than 98% of the internet connections in the country. So this shift changed the role and position of smaller and regional operators, and also this forced us to better understand how interconnection between us should work. And let's go back to the learning phase. In the early stages, we build the exchange based on our needs, on our practical needs, without having an understanding how internet exchanges should work. But later, in 2008, we joined EUREX. EUREX is a European organization of internet exchanges. And it has, I think, around 100 members. So we joined EUREX, and later we started to attend the RIPE meetings, and so we became connected to the broader internet community. I will tell you some things about our model. So Internet Exchange is owned by an association of internet service providers. Local internet service provider and regional internet service providers, they can become members of the association, and they can access the Internet Exchange platform based on their membership. Larger operators, they cannot become members, but they can have an agreement with Interline Internet Exchange, a commercial agreement, and so they can access the Internet Exchange platform and the whole ecosystem. At some point, local operators from outside Bucharest, because all this story started in Bucharest, in the capital, at some point we had operators from outside Bucharest who wanted to join. And this made it clear that not all the networks could be physically present in the capital. So they had to build, either to build, the participating in the exchange required a different approach. They had to build long connections to the capital. This is the map of Europe, and you can see Romania. It's similar in size with Belarus, and UK is the same size. So distance between cities in Romania are relatively large. So usually we have 3, 4, 5, maybe 6,000 kilometers between cities. So for operators outside Bucharest and operating in those regions, they had to build long-distance connections to the capital in order to access the Internet Exchange platform. So they had limited options, and these limited options, all the options increased costs and reduced the benefits of the direct interconnection. So what did we do? One possible approach would have to build local exchanges in those cities, but in practice, this was not a very strong option. Why? Because in those cities, there were only 2, 3, 4, a little number of local players. So building exchanges for a few operators was not something doable. So instead of building local exchanges, we decided to extend the peering platform outside Bucharest. So we created additional point of presence in other cities. So in this way, we allowed operators to connect locally and remain part of the same exchange. Our goal was to provide, of course, access to the ecosystem, not to fragment it. And our distributed layer 2 platform includes multiple points of presence. This is Interline in Bucharest. The main in Bucharest we have 7 POPs, but the thing is we have 10 regional point of presence. And in all these point of presence, we have 25 players out of 140. We have 140 operators in our exchange platform. Over time, this approach allowed us to expand beyond Bucharest. And today, as I said before, we have 140 operators. And participants are not only from Romania, but also from our neighboring countries, from Bulgaria, from Serbia, from Hungary, from Moldova, and from Ukraine. This platform helps smaller operators to remain part of the interconnection system, part of the exchange, and also to be active on the market. And it lowers the barrier to participation. And at the same time, the presence of many local operators makes us interesting for the more attractive for the content providers from CDNs and big transit providers. This model allows a large number of players to remain active on the market, even if we share only 2% of the market. And at the same time, it creates an environment that it is relevant for CDNs, for transit providers, and for big players. And of course, this combination increases the overall value of the internet exchange. So what lessons we learned from this story? Interland was shaped by the specific conditions of Romanian market. And it reflects a country with long distance between cities and the capital, and at the same time, a country with a strong concentration of interconnection in the capital, in Bucharest. So, extending the main exchange outside Bucharest was more effective than building those local exchanges in every city. And Interland started as a group of local networks solving practical problems. We had no idea what we will do next, and in time, Interland emerged as the structure out of that community. And its distributed architecture was not the result of a single design decision, so it was the result of the adaptation to the way the network evolved and the situation on the market. This is our story in Romania. Thank you very much for listening. And if you have questions, I'm here to reply, to respond. Or if you have questions later, you can meet us and my colleagues, Angela and Andrei, here. And we can meet later at the closing reception.
Yeah, we are not moving yet for the closing reception because we have what? What do we have? Yes, who started it? Who has started? I have heard that from this side.
Thank you very much.
And not only that one, but we have also what? We have thumbs up. We have thumbs up to you, Eric-Jan. And we have some questions maybe also to you. Yeah? So I personally remember when you have started the first RONOC. I guess
yes, it was 2014.
14?
Yes.
I guess it was just next to some industrial event you have started that was in Romania, right?
No, actually, you know something, but you don't remember.
Yeah.
It's a very long
Tell
time.
me.
We started with, we hosted EuroX meeting.
Exactly.
In Bucharest, and they asked us, do you have a NOG in Romania? Oh, what is a NOG? We don't have a NOG. So, okay, let's do a NOG. I mean, let's found a NOG in Romania. So we, with the help of EuroX and EuroX members, and we started to organize, and we did it, and it was very successful, and the participation of URX members helped us a lot. And after that, RONOG 2 and 3 and 4, and now we have RONOG 11.
Was Interlan founded before or after that?
Interlan was founded in 2005.
5.
So
Okay.
9 years
Yeah.
before.
Okay. But why I'm asking this, because, you know, the factor of a personality is quite, or not even the personality, a factor of doing something is very, very important. I can share also my own experience. I was the founding director of Armenian Internet Exchange, and the idea of Internet Exchange was discussed in Armenia, I guess, from 90s, 1995, 8, 2000, etc., etc. So each and every time, I was working at 2007, 2012 as the deputy director of the Union of IT Enterprises of Armenia, the largest ICT union in the region, and we were at each and every of our meetings, the operators that were gathering, that were discussing, well, you know, they were drinking something and telling that, okay, it would be good if we have an IXP. It would be good if we have an IXP. Let's think about that. And after they were leaving this meeting, nothing happened. And again, and again, and again. And at the end, when they have started once again in 2010 March, at one of our meetings, we told them, guys, do you really want to have this IXP? So if you really want to have this IXP, you should do something. You should make a step. You should make a second step. You shouldn't leave this event and do nothing. So we have told them, that, okay, if you want to make it, we will make it. So we have founded this IXP. We have made this step. So that is why the question of the personal approach and doing something is very, very important. They did it. They did it, and people, organizations, institutions are supporting people that are doing something. If you have something in your mind, it will not happen. If you see that cybersecurity, RPK is, yeah, in principle is quite good, or if you know that you should move in future for the IPv6, but you don't make it because, okay, I still have some IP resources, I don't know what will happen in future. More and more companies, leading telecom companies, are moving there, are implementing RPKI because they see that the challenge is not for something tomorrow. It can happen today, it can happen the next day. You should be prepared for that. You should prepare your network for the future development, for all this AI that we're discussing, for all this stuff that we're discussing. The regulation, it should be ready for the next year, for the next stage of this digital evolution, revolution, etc. And if you want to found the IXP, if you want to found the NOG, meet the like-minded people, just make this step and just do that. Do it now, do it after this meeting, do it with our support or without our support, but we are ready here to support you. And we'll be ready with all our support, institutional support, people, partners to support you. In many cases, we don't know how to do that. And Eric and Eric's team is one of the bright examples that can be shared with others. They are not only developing themselves, but they are also supporting with their knowledge, with the experience, with the troubles that they met with others. Because, well, actually, when we go some way, we don't know what type of troubles we can meet. We are just passing through these type of troubles. We don't, especially, I don't know how it is here, but we in Armenia, and not in Armenia, okay, me personally, we can happen it in each and every country. I try to overtake these troubles myself. Although I can ask them, ask people, and they will be helpful to me. They will tell me what to avoid, and this is not only about me, but this is also helping them to engage with you, and they feel themselves good. Me personally, I feel myself good when I'm helping people. Please support me so I can feel myself good. Ask for my help. I'll be pleased, and not only for my help. We have here people from our staff, from RIPE NCC. We have people from RIPE NCC board, even two. We have our managers and staff members that are really supportive. I cannot remember any case when we got the request and couldn't even try to help them. We always try. Sometimes it cannot happen, but we always try to make this happen. So please help us to be better, help us to feel ourselves good, and help our participants also feel ourselves good. And you have mentioned when it will be, right? Ronak?
29th of September.
29th of, are we inviting them?
Yes, of course. And after Ronog, we have the Internet Measurement Day.
Yes, and after Ronog, we have Internet Measurement Day, exactly.
On
so
30th of September. Just have something to share, to add. So we started to build the connection between us, but we didn't have the association at the time. And at some point, we were meeting and discussing we should form an organization to have a legal form of our interconnection, and the day after nothing happened, and we had many discussions, and at some point I said, look guys, I will go to the notary on, I don't know, tomorrow, in a few days. This is the date and the time. So if you will be there, you will be able to sign the founding document. So
You did the step.
Yes, we met like 7 people and we founded the association. And several months before, another 20 joined because it was a different situation. But yeah, the first step was very important.
Yes, and this is, I guess you can join me in this approach, because this first step is very, very important, and it is everywhere, not only in the business. Just try to remember the moment when you approached your I don't know, girlfriend, or do you remember that? How you made it? How? You did the step, right? Or they did the step? No? They told you, let's marry? Or you tell them? I mean, her. Huh? You did it. Okay, and what about you? Did you make this step, or it is still the future? You did it. You are currently married. Was it difficult? Not at all? You're not shy. Yeah, okay, okay. Who is shy? Who did this with difficulty? Who did this? I remember myself when my first love was when I was, I guess, 15 or 16. So I was avoiding her. Oh my God. It was a challenge for me even to see her. So what about you? Was it difficult to say, I love you? No? Was it difficult to make this step? First time. You don't remember?
Don't remember. That was so far away.
So everything is difficult, but you should, I guess, do that. Sorry, a lot of people here are elder than I myself, and they have a huge human path in this world, and they can also teach me. But I'm sharing my own examples. They can also share their own examples. But it is always challenging to do this first step in everywhere, in private life, in business. And what I see from all of you, most of you are people that are making their steps first. It is difficult, but the world is for the people that are changing it. that can say, I love you, that can say, let's do that, that can go to the registry and sign this paper. And in that case, they will have a success, right? They may fail. Yeah, one moment. Oops.
Thank you, Vahan. Just a quick question. Do you have a NOG here in Lithuania? There is a NOG, Baltic NOG. Yeah, but it was the first edition last year. So it's just started. So this is the, okay, so you already have a NOG and it's for the region, for all the countries in the region. Okay, good. It's good. Paulius, right? He's Paulius from IPXO. He started because I wanted to say if you have any questions or you need any help with the NOG, but actually at the beginning when the Baltic NOG was started, we helped them with some informations and important tips so they can start the NOG. It's good that you have now a meeting so you can go every time and share your thoughts, your problems, so it's very good for you.
But who haven't heard about this NOG from local participants?
Who was at the Baltic NOG? You?
You.
So few people here already. Good. Thank you.
Yeah, it is okay. And who is participating in the association? I guess you have associations, right? No? You don't have an association of telco companies? They say they don't have. You. We have the association. From which country you are? Sorry? Lithuania. Okay. Okay. And that is also the step, by the way. That is also the step that you can make. If you feel it worth, if you feel that it is important, just don't leave it to somebody else, you know, because, well, once somebody is anticipated to do something, it may take forever and it will end with nothing. That is why this first step is important. Okay, I guess we have discussed everything from first love to the creation of the association and to to making the steps. But it's quite interesting also to understand, you know, because why we are talking about all this, because a lot of things in this region is done not only because this is important, because this is business-oriented things, etc., but because it is also human-centric, because we need people, we like them, we have the friendship relations, we understand them, and this is, I guess, the most important thing we will have in future with all this AI development, etc., the humanity. And that is why I also want to understand your path, how you came to this field. What do you want to do and what is the future of this field? Are we working in this right direction, or you think that, for example, RIPE NCC will not functioning in 5-10 years? We should also understand that. Do you think that we will have a lot of challenges here in 5-10 years? What we are going to do, and for example, how you came to the industry, how you have decided to become Alex, the telecom professional. How? Why not chemistry professional? Why not, I don't know, doctor? Why telecommunication?
I was too young when making this, but I don't know, maybe, probably I can bake good bread or something, work in the hospital, but it was when the internet was only in the development stage, and nobody knows what is the spam or, I don't know, hijacking or something like this. So that's my story.
What do you think about the future? Do we have a future, or it is challenging?
For telecommunication, yeah, I think so that we're growing, and nobody can tell like 20, 30 years ago that you will have IP address in every fridge and every device at your home, but now it's reality. Okay.
So the devices will not eat us. We'll eat the devices. They work for us, yeah. Okay, thanks so much. I see we have here Hisham, and do we have already closing slides? We have everything. So Hisham, please make the closing. Please applauses to Hisham and applauses to you.
Hello, everyone. I have the pleasure of doing the closing remarks for this meeting and showing some numbers of what we actually managed to do at this meeting. Again, my name is Hisham Ibrahim. I'm the Chief Community Officer at the RIPE NCC. And what I wanted to show is the following. We managed to welcome 76 participants from 9 countries at this meeting. 42 of them were newcomers, people that have never participated at a RIPE NCC organized event before. 30 of the participants were from Latvia, and we also welcome attendees from Lithuania, Estonia, which we wanted to do because we wanted this to be a regional meeting for the Baltics, but we're also very happy that we have people from Romania and Italy coming all the way here to attend this meeting as well. So for me, this is a great achievement, and thank you all for joining us. And a few photos from the event, and while we applaud each other. I have a couple other numbers that I think are also really good to show here. We had a total of 33 participants at the trainings. We trained on IPv6 fundamentals, and we trained on BGP, routing security. As you can see, the numbers 13 and 20. So we managed to do that, and we're very happy that 8 people managed to get the certifications while they were on site here. So that is also a really nice accomplishment. So congratulations to whomever managed to do that, and again, round of applause for them. And a reminder for everybody here that has now heard about the online training and the engagement that we're doing. You can go online, it's free of charge. You can get certified in any of these topics that you see in front of you, whether it's IPv6 fundamentals, advanced, or security, but also BGP security, database, and the LAR course. We also had 7 participants take our usability testing outside with my colleagues, so thank you for everybody that participated in that, and 10 people that did the ARCs, the assisted registry checks that we have to keep the information up to date, and you've all heard why that is very important from us, from our colleague Jeremy earlier yesterday. I would like to thank my team from the RIPE NCC that managed to put all this together, so please join me in welcoming and thanking them for everything that they've done. They really put a lot of heart and effort into making this happen, and what I will be asking you to do is if you can take out your phone and take a quick survey to let us know how the event played out for you, what you think we got right, what you think we got wrong, and would you recommend to your colleagues to come for a future event? Vahan might be giving them socks, or give you socks if you recommend others, if I remember correctly.
Please, everybody is taking this. Who is not taking it yet? Have you all taken it?
It will only take a couple minutes, but it does really make a big difference, because we then go back and report on this, and it helps us do better for future events and meetings. Take your time. I think this is my last slide.
All the things, what was good, what was bad, what you propose to improve exactly in details, right?
Sure, it's not a long essay, it's just a few questions.
Yeah. Reception only for people that have filled this, right?
I think everybody's going to get a reception, but we do appreciate people filling it in. And as people are finishing the survey, just a reminder, we have the Right 93 meeting coming up in Sofia, Bulgaria. It will be towards the end of October this year. And also, we're sailing back to the Baltics next year, as you've heard us say. So we'll be in Vilnius, Lithuania. So please, we would really like to see you all. Oh, Eric, please.
I have a short comment.
Please.
Sorry. At the end of the survey, there is a link to RIPE 91, but the next one is RIPE 93 in Sofia.
Oh, yes. Oh, thanks for that.
In the survey, not in the slides, in the survey.
Thank you for that. We can adjust that, but thank you so much. And with that, the slide that you've been all waiting for, the reception, closing reception. Thank you all for staying to the end of the event. A warm round of applause to all of you, and please join us for some nice refreshments. Thank you. This meeting is officially over. Thank you.